supervising thing and making sure you're actually competent in the jobs they're asking you to do. Lack of skill, knowledge, and care can result in severe injury or death. It's true. It's, however unlikely it might be. If you're lifting heavy things and moving them around, you can really hurt people and product. So be careful. Report all incidents, including near misses. Absolutely. If we have anything significant happening with a crane, we want to report it. We want to learn from it. If things are falling or dropping, we should be freezing the scene and safing the area out and doing an incident report and an investigation, especially if there's property damage or anything like that. These videos they put in these things. There's a video that, again, it is included. I'll see if I can find it on break. It just shows an expensive turbine getting dropped by a crane, which is...
That's a good one.
It is a good one.
It's a good one.
Yeah, I think most of us who've been through crane course before or even trade school have probably seen it. It's an incredibly expensive piece of equipment where the rigging breaks and the thing falls into its housing and probably fucks up $1 million turbine assembly. So, not what you want to see, or not what you want to be a part of anyway.
I just saw one where they're pulling an excavator.
Okay.
It seems like an old missile silo.
Yep.
And then the straps break, and you see the excavator go and then fall straight down the missile silo.
Thanks to the advent of YouTube and all that good stuff. If you look up on YouTube crane incidents or accidents, or forklift for that matter, there is a assload of video out there of things going wrong with cranes. A lot of them you can see what they did wrong pretty obviously. They're pushing things to their maximum capacity and way beyond. But a lot of them it can be pretty subtle. The main thing is take what you learned yesterday from rigging, do your inspections, know your limits, use higher capacity things than maybe you think you need because everything gets derated as it gets damaged. So don't lift a 1,000-pound object with a 1,000-pound sling. Lift a 1,000-pound object with a 2,000-pound sling. Just take your time, ask questions. So from 2000 to 2020, there was 38% of injuries were crushed by the load from load swing and load drop or by unstable load being placed and falling over immediately. And that's huge stuff. I mean, that might even be things like clamps letting go. You just have to have your wits about you when you're using cranes. A lot of what we do is pretty small, but we do the odd big lift, and we just have to be cautious. Occupations of those injured or killed. So 60% of the people injured were crane operators, 14% were maintenance employees, 8% were riggers or signal people, and 6% were production employees. So obviously the most at-risk individual is the operator himself, probably because they're the ones putting themselves in harm's way. Just be mindful of that. Head injuries are the most common, hands and fingers, because that's what you're using to manipulate the load, legs, feet, chest, and other. Other could be obviously anything. I guess it accounts for the biggest one, but pretty vague. 72% of incidents happen during routine job activity. So that's probably partly due to complacency. People get used to doing things the same way and just don't stop and think. Some small things, sure, it's probably not likely to hurt you, but if you're doing something different, if you're doing something for the first time, if it's your first one of the day, whatever, try to treat every lift like a new lift, even if it does seem simple, and always look around and communicate with the people around you, so we're not putting our coworkers at risk. Here, and see that they include a video, so I don't know why they can't just include the other videos in the damn thing for me. Those look like concrete based on the way they're just like coming apart, so they're probably pretty darn heavy. Not something you want to be. Everybody's just hanging out like a bunch of city workers, chatting, shooting the shit, not paying any attention to what's happening around them.
Overhead lift right beside them.
Right? I mean,
that's kind of ridiculous.
That would be a simple look out for your. And they're probably all shocked that this was happening, but they're all having a little safety meeting right next to where these things are happening above them. Complacency. I mean, it's probably a normal thing they've done before. Talk to your coworkers. Hey, Bob, get the fuck out of the way. We're going to lift this thing right here. Don't be there. And thankfully, it wasn't directly overhead, but it sure was pretty close. And they were all pretty lucky to escape. So legislative requirements. The obligation of the employer, being LJ, is to protect the health and safety and welfare of workers and others in the vicinity of the workplace, ensure workers are adequately trained. That's why you're here. And we do this every 3 years because things change, and it's good to have the refresher. A lot of us will forget the details of the rigging we learned yesterday. It's good to have a refresher and go through it again. Ensure workers are competent, and again, the competency is the big one. Just because you're trained doesn't mean you can actually apply what you know. You have to be tested, you have to be observed, That's why we do the testing, that's why we do the observations, and why ultimately your supervisor is the one who's responsible for knowing you can or can't do something. That being said, you still need to communicate with your supervisor and say, hey, I've never done this, I don't feel comfortable, help me out, and they'll help you out. We're all here to look out for one another. Ensure hazard controls are in place and practice due diligence. Due diligence is a pretty loaded statement, but it just means everybody has to try to do their best and try to look out for one another and not cut corners and, oh, we'll just fly that concrete over top of Bob's shoulder and not his head. Obligations of the supervisor, identify and correct hazards. Work with the Health and Safety Committee or representative to address worker concerns. Monitor the worksite for substandard conditions and acts. Enforce policies, rules, and regulations. And assess competency. So that's a big one here. Your supervisor should be assessing your competency. Obligation of the worker. So this is what falls on you guys, no pun intended. Protect health and safety of themselves and others. Again, talking to your coworkers in the area, saying, hey, bud, I'm lifting this. Just, heads up, or please move. And give me a few minutes, I'll be done. You can come back, go for a smoke, whatever. Follow safe work procedures, report unsafe acts and conditions, obey company safety rules, report any incidents as soon as possible, make suggestions and voice your health and safety concerns, and set a good example. Obviously, the more senior employee you are, hopefully you're setting a good example for new people. An unfortunate reality in industry is the senior people are often the ones breaking the rules because they think they can, because they're complacent, because they think the rules don't apply to them because, hey, I've been here for 50 years, I can do whatever I want. You should be setting the bar high for the guy who's just come in yesterday, because if he sees you doing something wrong, he's going to think it's okay. So it's up to those of us who've been here for a while and to set a good example. Basic rights of workers, and this is OH&S law, is the right to refuse, the right to know, the right to participate, and the right to refuse. So the right to know is workers have the right to be informed of worksite hazards and methods to eliminate and control them. That's where JHAs come in. In theory, they document all the tasks, the risks, and the ways to mitigate those risks. The right to participate, workers have the right to be involved in company health and safety initiatives. They have the right to refuse dangerous work. Workers have the right to refuse dangerous work and are protected from discriminatory action for exercising this right. Again, this one often is mostly exercised. You have a lot of sketchy employers out there asking their employees to do things that are overtly dangerous. A roofing company is a good example. Little Timmy's going up there. He's 16. He's spry. He doesn't need fall arrest. Yes, he does. He needs it more than anybody. He's young. He doesn't know what he's doing, and he can fall like anybody else. So, unfortunately, that's where they hammer this into us, regardless of just being a crane course, is you do have the right to refuse if you're put in a position where you don't feel comfortable. In most cases, especially in a decent company like LJ, it's going to be, I don't feel comfortable doing this, please help me or teach me, and that's all that's going to happen. It's going to be a conversation. But if it's something more than that, where your boss is basically threatening your existence and your job, because you don't want to do whatever sketchy thing they're asking you to do, you have the right to refuse. And you can talk to the government about that if they're trying to threaten you with your job. Hopefully that's not happening around here for any reason. Cranes and hoists must only be operated by a competent worker authorized by the employer. First step in that process is this course. If the operator has any doubts as to the safety of other workers in the vicinity of the lift, the operator must not move a load until working conditions are safe. So again, communicate with your coworkers, make sure everybody's out of the way and is aware of what's going on. A load must never pass over a worker. That's pretty much rigging 101. We cannot lift things over top of people. Rigging must not be subjected to a load greater than the rated load marked on the tag. The rigging maximum load rating must be legibly marked, so that just touches on what we learned yesterday. Rigging must meet the requirements applicable to the American Association of Mechanical Engineers standards and must be thoroughly inspected before use. So it's up to you as the end user to know what you're choosing from the rack is going to do the job you're asking it to do. Hoist is a lifting device used for vertical lifting and lowering for a freely suspended load. We have our electric chain hoist and electric wire rope hoists. The combination of those is what all of our cranes use. The jib cranes and whatnot use electric chain hoists, and then the bigger ones use the electric wire rope hoists. A trolley is a wheeled carrier that moves a hoist along a supporting structure, typically an I-beam or a pair of I-beams, and it's motorized and can support the load as it moves along the beams. Workstation cranes, there's different variations on a theme for workstation cranes, usually the smaller ones. We do, of course, have jib cranes in welding and machining. And then the Gorbel style crane, this is exactly what we have in day one for shipping and service. And then we have a variation, a slightly bigger one. Oh, pardon me. Take the glasses off. A slightly bigger one out in rentals. They're big and awkward and heavy, but they are workstation cranes. Gantry cranes, we don't have any of these around here. I think we built something kind of similar to this back in the day, but we also looked into buying these for rentals, but we didn't end up getting them. Overhead bridge cranes, this is exactly what you're going to see in all the bays pretty much around here. You'll notice if you go to assembly, building 2 anyway, we have the 10 tons of this style with the underslung trolley and the 20 tons of the double girder with the trolley on the top. So some of the different parts include the bridge or girder itself, the trolley, the hoist motor and brake, the rope drum, wire rope, hook block, pendant cable and strain relief, the pendant, the remote control if it's applicable, which none of ours have, the hook and the hook latch, the sheave, the bridge drum, the collectors, the conductor bars, the end truck, the runway, the bridge wheel, the end truck bumper, the bridge end stop, pendant festoon, trolley festoon, and runway rail. If you're doing previous inspections on these, it is beneficial to know what all the parts are called so you can document any problems. Not that you can actually get up there and check every one of these, but it is helpful to be able to use the right terminology. Safety devices, the emergency stop button or e-stop on the pendant or remote control shuts off the power of the crane when it's pressed in. The e-stop is self-latching and should be pressed in when the crane's not in use. It is a good practice to power off your cranes with the e-stop when you park them, when you complete whatever task you're doing. Hoist limit switches. The hoist has an upper limit switch that shuts off the up function to prevent the hook block from striking the hoist. Yeah, we don't want to try and run the hook into the drums. Some electric chain hoists have a travel limiting clutch. A lower limit switch shuts off the lowering function before the hook touches the floor. If the hooks could touch the floor, then it would basically take all the cables off the drum and mess up the way everything is reeved through there. So we want to avoid being able to do that. That being said, you could still, the hoist, if you were using a crane here, you might not be able to touch the floor, but you can still touch an object beside it, and that way if you put the hook on an object, you can still have the option or the ability to bugger up the way that the cables are all fed through the block. So try not to put your block down on anything, never mind the floor. Load limiter, or overload protection, prevents the crane from lifting an overload that could damage the crane. When an overload is set, the load limiter shuts the up function off, but allows load to be set down. So in the unlikely event you get it off the ground, it'll still let you put it down. I don't think I've ever seen our cranes actually activate this because we never lift anything that heavy. But
Is that in assembly?
I kind of feel like they must, strictly based on the quality of them and the fact that they're not cheap and they're like, I don't know, they're pretty big.
Yeah, I've never seen that.
But we've never tried to
But
lift
we've
anything.
never gone to over the limit.
No, yeah, that would
Like,
yeah.
And I'm sure there's a factor of like, if it's not like the second you hit exactly the 10-ton mark, it's going to stop. But then again, we've never taken them that high. We always, in worst case scenario, we use 2 cranes.
Yeah.
And we've done that, but then it winds up being like half the capacity of the crane. We just don't have anything around here heavy enough to trigger that. I guess you could come in to like one of the 5 tons in welding or something. We could probably find something outside that heavy and try it. But we've never had this at, right? Let's test it. If it doesn't work, we'll just bring the whole crane down or rip it up. But I'm not surprised. I mean, for the amount of money these things cost and all the other sensors they have, that they have this. Ironic because it would be nice if they had a built-in load cell, because effectively to be able to do this, it kind of seems like it would have to. But I guess it could just be literally an overload system where it starts putting too much draw on the motor and then shuts it off. But kind of like basically a breaker or a fuse. But honestly, I'm surprised more cranes don't have built-in load cells that tell you how much it's lifting, because it seems like something that would be pretty simple to add to an expensive crane, and it would save us installing load cells in between the load and the crane sometimes, but oh well. Anti-collision device prevents the crane from making uncontrolled or unintentional contact with another crane on the same runway or another hoist on the same crane. We don't obviously have multiple hoists on a crane here, but we do have multiple cranes on runways. Well, you can come through. It's all good. You want to sneak through? Of course, go ahead. You're allowed. Oh, heavens.
Ooh.
Come on through, fella. Fresh coffee. And we've had problems with these in the past where they haven't necessarily worked properly. Often we wind up switching the overrides on the controls on anyway, so we can bring the cranes close together. But we should always be mindful that we should definitely not be running the cranes into each other at high speed. Typically they'll slow down anyway, but shutting off the override will actually allow you to butt them up together. There was at one point when Richard was running the water jet, he did lose his anti-collision devices, and you actually could smack the cranes together at high speed. And he kept showing you, look, it still does it. Thanks, Rich. Not something you want to be doing because then you can bugger up the way the wheels are on the rails and stuff. But they should be functioning, so you should never be able to just run two cranes into each other at full speed. Honestly, I'm sure Garrett would have tried that back in assembly many times.
Yeah, we can
anyway.
The only cranes that we can get right close to each other is number 3 to 4.
The two at this end.
The 220 tons we can get right next to each
You
other,
touch
but
them
they run slow speed.
Yeah. And that's exactly what you want. So it's usually just as simple as an infrared beam running off a reflector, but it keeps the crane. But you can still, with the override off, they shouldn't actually, it will stop and it will stay stopped. You have to turn the key and make a conscious decision to override that control so you can bring them together. And as Shane pointed out to me, one of the biggest reasons for assembly having such controls on how close the cranes can get together is because every crane rail structure in the entire build or entire company, the cranes run on separate, on their own freestanding structures. Assembly, the crane rails are the building. So theoretically, if you were to overload the cranes or park all the cranes as close together as they can get and then maximize their lift capacity, you could bring the whole fucking building down. So not that we could ever do it, we just don't have the mass around here to do it, but that is part of the reason why they're pretty particular about how close they can get to one another, because those cranes run on rails that are physically attached to the structure of the building, whereas every other one in the building or in the whole place, it's a whole separate structure, a standalone structure. So that's one of the distinct differences with the cranes and assembly, or a building to assembly. Travel limit switches are optional, but the bridge travel limit switches prevent the crane from contacting the end stops. As far as I know, all of ours will totally allow you to hit the end stops, but they should only do it at slow speed. You don't want to be running a crane against the end stops, especially at high speed, because you can actually rip the end stops off over time. They're just usually little pieces of welded angle or I-beam or something onto the rails or onto the structure, and if you were to continually bash into that with the crane, you could actually eventually tear it off, and all of a sudden you wouldn't have an end stop, and things would get messy fast. So trolley travel limit switches prevent the trolley from contacting the end stops at the end of the bridge. We definitely have those. We need to make sure those trolleys aren't running into the electrified rails, make sure they're not running into the heaters along the side of the building. There's all kinds of reasons that we don't want the trolleys to go all the way sometimes, so they should have limit switches installed to stop that. But at the end of the day, as the guy using it, you've got to pay attention to what you're doing and make sure you're not running into things. Always have your wits about where your crane is, where it's going, and what's around you, and things move and change. So someone might build a rack there today, and all of a sudden there's something in the way. The bridge capacity is marked on both sides of the bridge and should be visible from the floor. The hoist capacity is marked on each side of the block, and they should match. All of ours are in imperial tons. Tons and tons. Ours are in tons, so they're all imperial, as per yesterday. And one imperial ton is 2,000 pounds. 1 metric ton is 1,000 kilograms. Operators using a 5-ton crane, a 10-ton shackle, and a 6,400-pound capacity sling. So what's the overall capacity of this lift? Anyone? Bueller?
6,400 pounds.
Correct, because
That's the lowest number.
Yeah, well, that's just over 3 tons.
Yeah.
So that's going to be your weakest link, and that's the important thing to remember, regardless of whether it's the crane, the sling, the shackle. Your lift is only as good as the weakest thing that you choose to use. So you can over-rig everything else and then pick some rinky-dink shackle because it fits the hole, and now your whole lift is at the mercy of that one little shackle. So always know what your weakest link is if you have to be creative and put multiple parts together. There's their crane logbooks, daily operator logbooks, or a record of pre-operational checks carried out by a crane operator. I'm not going to lie, we don't have logbooks. We have books for every crane. They're all in my office. We keep our daily operational inspections. They're all documented, they're all digital, and they're all saved in a shared file that everybody has access to. I think this is somewhat antiquated to have a physical book, but we do keep everything we find. And when you do your previous inspections, if you actually log a deficiency, I will look at them. I see every one that comes through. Usually I will decide if it's going to be something that has to get fixed right now or something that can wait. If you take it out of service and mark that in the log or in the inspection, then we'll wind up having a conversation and we'll see what the problem is. And if it's a safety issue that's requires immediate remedy, I guess, we will get the techs in here and have it fixed right away. If it's something minimal that's not actually causing a safety concern, it might end up waiting until the next service is done or until something else goes wrong, because we pay to have the tech show up and we don't need to have them here fixing tiny things when we're going to wind up having them here fixing something bigger. But as per everything else, if you are in doubt, document it, talk to your supervisor. If you're not the person doing the inspections, Clark, I know you do yours every day religiously and you do a very thorough job, and that's fantastic. Scott, I know you've been on the hook for a long time, or were, I don't know if you still are, for doing the inspections over there.
Oh, yeah, Constantine's on it, so I
okay. You're the secondary now then?
Yeah.
Okay. So, I mean, I can tell some days it seems like they all come in quick succession, so I usually think, someone didn't look. Or they did the inspections and then came and filled the paperwork out. Either way, we should be always doing our daily inspections, making sure they're done. But if you find something you don't like while you're using it during the course of the day, talk to your supervisor. Don't operate it thinking, well, someone else inspected it and it was fine then. That doesn't mean they noticed it, and it doesn't, or it might have changed since they inspected it. If you find something you don't like when you're using a crane, stop, talk to your supervisor, get them to contact me, and if it's a significant issue, we'll have it fixed pretty much immediately. Our crane service guys are freaking awesome, and they treat us really good, so they'll usually be here within a day and get her taken care of. Maintenance logbook, record frequent and periodic inspections. Again, all this stuff we save digitally. Every time we get our crane service, we keep records of it all. It's all available. It's all in the safety folder, the maintenance folders. It's not hard to find, but it's not written in a piece of paper that you're going to find at the cranes. 3 types of inspections that must be completed. We have our daily pre-operational check, our frequent inspections, and periodic inspections. Pre-operational checks, a functional check performed by the crane operator at the beginning of each new shift. Again, with the exception of our machining night shift, it's going to be once a day this is done. Clark gets his out before most of us are even awake on some days, and checks him every day. Operators must, what's that? Keener? Well, he is a keener. It's all good. The operator must be familiar with most recent entries in the logbook before operating the crane. So if you need any information about your cranes, let me know. They have been serviced. I mean, we replaced the entire carriage assembly and hoist on the crane and welding because it was the oldest crane in the whole place, and it basically died and needed to be replaced. So now it's a shiny new one on the whole rail. Most of the other ones, it's only been sporadic, small changes. Frequent inspections, visual and audible examinations by maintenance personnel between periodic inspections, looking for defects, malfunctions, and damage to the crane. We basically go on it. If someone tells me there's a noise, we'll get it looked into. If it's a new noise, an old noise, whatever, we will try to get it taken care of. It basically requires communication between the people using it and maintenance being myself. I'm not running around checking these things, and I'm not qualified to check them necessarily. We'll just call the experts and have them come and check it out. Normal service monthly, heavy service medium monthly, and severe service daily to weekly. Periodic inspections, visual and audible examinations carried out by qualified crane inspectors at least annually or more frequently depending on use. We get all of ours done annually, but that being said, again, if there's any cause for concern, if your crane's acting up, if you find a big oil leak or something, shut it down, talk to your supervisor, and we will get it inspected and taken care of right away. So for normal service, which is what ours are considered, we do them annually. And this year, everything they found that was wrong, we decided to have fixed. So we checked all the boxes and had every single little problem they found taken care of. So hopefully everything's up and running as well as it can be. When you are doing your pre-operational checks, make sure you're looking for things like oil drips. We did have one in welding there right after they fixed it. And it turned out it was literally because they'd installed new parts and oiled them really, really well. And then we went for a weekend and it sat there pouring all that excess oil off on the floor. So Monday morning, Clay dragged me in there at 6 a.m. Look at the oil leak. Fair enough. There's no harm in checking. It was a pretty significant one. but it turned out it was just the excess they had put on it when they were doing the maintenance. But that's fine. Shipping did the same thing to me a year or so ago. After the maintenance, there was a bunch of dribbles on one of their carts. Whatever. If you don't like the way it looks, ask. And there's no harm, no foul. You never know. Maybe the maintenance guys bunkered something up. Better to ask and know than be thinking, well, it might be broken, but I'll run it anyway. That's definitely not the way you want to operate cranes. Disconnect switch, look for clear labeling, clear access, lock tag indicating defective. If the cranes are defective, we will lock them out. Usually the disconnect switches are pretty accessible. We should always maintain clearance around them so they're easy to get at. We've gotten a lot better at that recently instead of burying them behind stuff. Of course, that being said, some of our crane disconnects, like the ones in welding, are literally on the fuse panel at the back. They're not a big, huge switch like they are in building 2. They're just a breaker on the fuse box. So, you know, you have to, the most important thing is know the area you work in. I assume you know where the disconnects for your cranes are because it's in your bay. Your guys' are pretty obvious, but still, you should know where they are in case shitty things happen and you have to actually throw it. We do tag them out sometimes for service reasons. That's about it. Conductor bars, check for sharp bends, damage, insulation, support hangers. You're not going to get up there and look at them. You just do a visual inspection, click around, make sure everything looks straight, everything looks like it's aligned properly. Again, get to know the crane you're actually using. They're all a little bit different. Collectors, check that each shoe is properly seated, shoes are parallel to one another. The pendant festoon, look for bent tracks, smooth rolling trolleys, and equal lengths of loops. If they're not equal lengths, then it implies something has come loose or broken and things are hanging the way they're not supposed to. Pendant cable and strain relief, ensure there's no damage, tears, or cuts. The cable is long enough for easy reach of the pendant, and the strain relief is securely attached and holds the weight of the pendant. Again, you can see it pretty clearly in this picture. There should, for these big ones, and this is pretty indicative of what you'll see in assembly in most places, you're going to have a very obvious metal cable that actually takes the weight of the pendant, so it's not hanging by the electrical cables. Some of our smaller cranes, the wire is built into the cable, but either way, there should be a means to take the mass of that thing, so it's not just hanging the weight of it on the electrical cables. If you do have a remote control, well, you can do inspection of that too. Look for housing or button damage. Buttons are clearly labeled, the buttons are not sticking, and the e-stop button is pressed in and latched, so make sure your e-stop actually works properly. There's no exposed wiring for obvious reasons. The e-stop button itself, check that you can release the e-stop button, press the up slow, while pressing up slow, press the e-stop button, and the hoist must stop. So this is a test question. The only thing that should stop immediately is the up and down. Everything else, it can't stop immediately. If you're rolling a crane down a building and it stops dead in its tracks, your load's going to fucking shock load, do all kinds of weird things. Pretty much every function of the crane, like north, south, east, west, will roll to a stop. The e-stop button must stop the crane up and down immediately, but it will not stop the movement of the trolleys and the bridge. Dependent or remote control function, release the e-stop, try each button to verify the functions match the labeling and the directional sign of the crane. So again, get to know the crane you're using. Everybody who grabs a new crane usually fucks up their direction at some point because they're hardwired for a crane they used somewhere else or in a different bay. Double check when if you're going to be, I'm sure Clark knows his crane very intimately and can do it blind. But if it's your first time in a bay, if we took him to assembly, he wouldn't know which button does what. So take time, get to know the one you're using, and make sure everything goes in the direction it's supposed to. The hoist function, try slow speed and fast speed. Listen for unusual noises. When the push button is released, check the brake stops to hook immediately without any drift. You should never have drift on your up and down. Upper limit, raise the hook block and approach the limit switch in slow speed. So it should stop before anything ever comes close to getting into this. You do not want your hook to contact the drum. That would be pretty bad for everything. Test it in fast speed also. So you can make sure it works in slow speed and then make sure it works in fast speed.
Ours have a speed limit.
It slows down when you get close to the top.
You'll be going half speed or full speed, and then when you get close to the top, it slows down.
But there's 7 speeds on your crane. I can't count the number of times I was told by a certain individual. There's like five positions on those buttons.
I can show you.
You can find all 5.
I can show you how to do it.
You are that delicate. I can only find 2, up slow and up fast.
It's not so much with fast, it's more of the travel. It's not the up
Oh,
and down.
okay.
It's the travel speed. I can get it going from slow, and I can incrementally speed it up.
No shit. Okay, no, that's fair. Okay, I always took it as it was the up and down, but there's only up slow and up fast. Or,
Yeah,
You
no,
like let go of the button and it kind of slows down, and you re-press on it, it'll stay at that slow down speed. You let go,
Okay,
it'll slow down. You go
You
again.
guys have gotten to know those ones more intimately than I have, that's for sure. So that must be what he was talking about. I always thought it was the up
or
and
you can
down.
speed it up the same way.
Exactly. Yeah.
Okay, no, fair enough. And that's good because that's testament that you guys paying attention to the ones that you're intimately involved with every day. So it means you know your cranes. So that's fantastic. Trolley travel, move the trolley in slow, then fast speed. Listen for unusual noises. Check that the trolley stops without excessive drift. Again, that's all relative. If you really wanted to, you could look at the manuals, which we do have, that would tell you how far it's supposed to drift. The main thing is it doesn't just keep going and butt up against the stops, but it will drift, and that's because you don't want the trolley to stop immediately, because that could cause shock loading. And if you were using a magnet or something, and your trolley stopped immediately, you literally might have your load fly off the magnet when it stops. So you don't want it to be able to do that. You want it to drift slowly to a stop. The trolley festoon, check for bent tracks, smooth rolling trolleys of equal length and cable loops, just like any other festoon. The bridge travel, similar to the trolley travel, move the bridge in slow, then fast speed, listen for unusual noises, check the bridge stops without excessive drift, and do not run against the end stops. Check the function of the travel limits if there are any. So you can bring it close to the end stops, try to avoid actually running into them, especially if you're moving quickly, if you can. Anti-collision device, make sure the crane, or move the crane towards other cranes on the same runway in slow speed, verify no uncontrolled contact is possible. I know one of the tricks used in assembly to get the cranes closer together without the overrides is to run them at each other at high speed, because then it drifts farther and you get them closer together. It's fine, we do it all the time, frankly, and it does get them closer together, but then you have to turn the
But
override on.
they've never contacted.
No, they don't. But you can get it, if you go slow, it'll stop 10 feet apart. If you go fast, it'll stop 5 feet apart.
Or more.
Yeah, no, I know. But
Well,
you
and
basically,
it's really just because of space.
oh, no, of course.
You got all 4 cranes running, and you're trying to get to where you need to be. And
You gotta take a run at
take
getting
a
it
run at
closer.
it, and then
Yeah.
you can get away from them.
No, that's fine.
So,
It's testament to the fact that everything's working properly, that you, even at high speed, they will slow down and stop
yeah.
10 or 15 feet before hitting each other. If you want to get them right up against each other, you have to override. And then you're making a decision, and that's trusting the operator knows what they're doing. So it's all good. The hook block, look for damage to the housing or the sheaves, the rope compressions in the sheaves. Yeah, you don't want, if there's marks inside the outside sheave here from the rope, that's a pretty good sign something's wrong. You don't want to have things wearing up against each other like that. Make sure the wire rope's properly seated, the sheaves turn freely, and the capacity markings are legible. The hook and the latch itself, look for cracks, nicks, gouges, rare or unauthorized alteration. Can't imagine anybody would alter the crane hook, but it's been done, I'm sure. Deformation, excessive throat opening. You always look for excessive throat opening. Hook turns freely. Figured that would get a crane any day. This thing's dirty. The latch is strong, spring action, and is not bent or damaged. Lower limit switch, check that the hook stops above the floor. There should be at least 5 wraps of rope on the drum as required by the manufacturer. Again, every crane is probably different, but you don't want to have it down to the floor and have barely anything holding on. You want to have a few wraps of the cable around the drum. Wire rope, check for damage such as kinks, permanent bends, loose stranding. Wire rope is seated properly on the drum and not crossed over or skipping grooves. Again, yeah, you don't want your crane cables to be in poor state. And again, that's part of our annual inspection. They get in there and they basically physically handle every inch of that cable that's exposed, give it a twist, a bend, looking for broken fibers or broken strands. But if you can see it from the ground, if you've got kinks in your cable for the crane, I don't even want to know what you're doing. But the other things, this kind of stuff can happen, and we have had small internal breaks like that. Thankfully, because of our diligence with the inspections, it's caught long before it's a problem. When you have chains, look for nicks, gouges, bent or twisted links, arc strikes, or weld spatter, and all of which are possible if you're working in that kind of environment. That one on the right is, I can't imagine what happened to that chain to get it worn that much. That's just insane. It's down to like half the diameter, if not less. So that's pretty excessive, but again, it obviously can happen. On 2-fall chains, ensure the hook block is not capsized, so you just don't want everything to be cockeyed. Everything should sit pretty level, pretty even. If you do have bent or kinked or locked up links like that, that's obviously going to play havoc with things. Basically, any deficiency identified during a pre-operational check must be corrected before the crane can put into service. And there's, by and large, that's true. There's going to be some exceptions. But if you find that your cables are damaged, we're not going to use that crane. I think one of the most severe things we had happen here recently was, I want to say crane 2 in building 2 had fused contactors. And we'll talk about that at some point in this presentation. But basically, the big heavy-duty high voltage contactors that operate the crane, because people were either maybe clicking it too much, and frankly, it doesn't matter. Those things are old enough now. Shit will happen. But the contactors were actually sporadically fusing, so it would not stop when you tried to stop it, or it would go off by itself. We actually had to get it, even confused the guys doing the service. Thankfully, we did end up getting it figured out and get the contactors replaced. But the crane was basically not responding to the input of the operator properly, and that could be definitely problematic. So we immediately took it out of service and stopped using it, and got it fixed. And it was discovered the contactors were actually fusing, and I have those contactors in my desk because I thought it was impressive that this was actually happening, and they were actually melting and sticking together, which is something that people will tell you happens all the time, but there wasn't ever proof of. Well, we actually have proof here of it happening. So, lockout tagout. Follow employer's lockout tagout policy and procedures when deficiencies are discovered. With multiple cranes on the same runway, use lockout bags to isolate cranes. Most common time we do this is when we have people either up servicing the overhead doors or servicing the cranes. We can tag the bags out, or put bags on the pendants and tag them out, just to keep people from using the cranes, so we don't run a crane into some poor guy in a man basket trying to fix the overhead doors or whatever might be happening. Pretty rare we ever actually tag out the disconnects because we don't want to shut all the cranes down, but the option exists if we need to. Crane operator must ensure the safety of everyone that's affected by the lift. This includes those who may be in the vicinity. If there are any doubts as to the safety of the individuals in the vicinity, the operator must not proceed with the lift until conditions have been made safe. So you're on the hook for everybody around you when you're doing a lift. Talk with them, communicate with them, give them a heads up. Sounding the horn becomes basically useless. People don't pay attention. So just talk to your coworkers. If Charles is sitting there in his chair doing his programming thing, say, hey bud, we're going to lift this. He'll say thank you very much. And if you think he needs to get out of the way, he'll do so. He'll happily go for a smoke while you do your lift. You don't have to convince him. But it's just little things like that go a long way towards building team and looking out for one another and keeping everybody safe. You guys got to hit the gut truck today?
I got a lunch break.
I mean,
Break whenever you want.
Probably when the gut truck comes, we'll take a break. It's 1:45, but she could be here anytime. So, be knowledgeable and experienced in the type of load handling activities you're assigned to. So you need to know what you're doing with what you're being asked to do. If you're being asked to do something you're not familiar with, not comfortable with, no harm, no foul. Stop, ask, find someone who is familiar with it. Be familiar with the manufacturer's specs. Be familiar with hazard assessments and safe work procedures. So we definitely have the hazard assessments. We're working towards getting safe work procedures. And complete a field level hazard assessment when new or additional hazards are present. So we have our generic job hazard assessments, which cover 90% of what we do here on a daily basis. But if we're doing something outside the norm or something that's new to you, then frankly, you can always do a field level risk assessment or hazard assessment if you have to. If you need to take a break and stop and think your way through something new, do one. I mean, you're not going to do one every day for every lift. That would get excessive, and your boss would probably be unhappy with you. But if you're doing something new, there's no harm in doing one. It just forces you to think and document how you're going to do what you need to do.
It's essentially just doing when you're doing something other than
And that's just it. If this is something new to you or something big, I mean, one thing that comes up often in building 2 is, oh, we're lifting a vessel. So it's big and it's scary. Well, it's not. It's just a bigger thing. Unless it's, honestly, we do more weird things with parts and uneven loads than we do lifting something that's 20 feet long and 10 feet across and round. Those are actually incredibly simple. Now, if you involve 10 people, or if you need to involve multiple people, if you've got a couple of tagline operators, a spotter, the one thing about things that size is you can't see through them or around them. So sometimes it's helpful to have other people involved. That could be cause to do a field level risk assessment, if only because it forces the people involved to stop and talk.
Do we not have a a rule, or maybe this comes later with the lift plan part, where if we're at a certain capacity of the crane, that we absolutely have to do
I believe, I want to say it's above 75% of the capacity, but the numbers always escape me. But yeah, if you're doing close to capacity lift, it's a critical lift. If 2 crane lifts can be, some people consider those immediately critical lifts. It really depends on who's involved. It never hurts to stop and do the paperwork. If we are running things up close to capacity, we should be doing critical lifts. That's just to make sure we have the whole thing planned. You actually have to draw a little picture and do the math if need be, just to verify that what you're doing is going to be safe. And they do touch on that in here. But if you're in doubt, talk to your supervisor. They should know when to apply the right one. And frankly, there's no harm. If people doing the lift or think they should, fuck, do it. You know, doing that paperwork goes a long way towards proving the company is doing its diligence, and it's a testament to the operator to say, hey, I think in this case we should do it. And as much as certain people will wind up haggling over the validity of it, it's valid if you're the guy doing the lift and you think you should.
Well, and it's just the part that, and that's just a personal anecdote. You guys may or may not, I know that Vitaly probably will park is never in buildings. We have to do tests sometimes, and we have these big test vessels that are filled with cement that we have to bolt together. And sometimes the positioning, and they all have, most of them now have hooks on them that we can pick up and move. But there was one lift that I had to do where I couldn't use those hooks. I had to do something different. And so we had to go through, and with Ryan's help, we bought brand new
Higher capacity
slings so that we could live. I needed to rotate it and lift it. So, you know, and it was just talking to the engineers and talking to Ryan and find out what we need, and they made it happen. So if you guys run into that, you know, just the company is super willing to make sure they want the work done.
Exactly.
Right? And they want it done safe because, like, A, they don't want anybody to get hurt, which is correct. That's, you know,
Always job one.
always job number one. And 2, I mean, it costs money to make money.
No, LJ's pretty agreeable when it comes to getting the right tool for the job. Yeah, I can make jokes, but yes, we're pretty good with it. I mean, it's not excessive. That whole lift cost us $200 to buy the slings. It was fuck all. Now we have.
And it was 32. It was actually 32,000 pound lift.
Yeah, and that's just it. Because of the magnitude of it, if something had gone wrong, it would have made a big hole, like a big dent in the floor. It could have totally killed someone, and it was definitely outside the norm. So stopping and thinking and then deciding to procure new equipment, and just those conversations are worth it. You know, everybody has varying degrees of comfort with this stuff. I've been rigging things for 25 friggin' years probably now. No, you're not that. Well, 20 years of rigging, some of which has been incredibly large. I've done 2 crane lifts in the field using 2 like 60-ton cranes with 2 operators standing in the middle, patting my head, hitting my elbow, pointing at different cranes because this is main and this is whip line on a crane that has 2 hooks. Trying to orchestrate 2 cranes, it can get pretty hairy. Stopping, and for those ones we had to stop, we had to write things down. You know, we're lifting things that weigh 40,000 pounds or whatever. There's definitely a need to do that kind of stuff, but that could be for any lift if it's something that's new to you. And as long as it doesn't take 3 days, hopefully, but take the time you need, sit down, go through the motions, do the math, write things down, think about it, communicate with your coworkers, and documenting it just forces everybody to have to put a thought in. You can talk about it and then fuck off for coffee and then come back and everybody's already forgotten. Was I supposed to be paying attention? But at least if you're all going through the motions and writing it down, it's a good exercise. And that was a prime example of where it was necessary to do it. But yeah, it's all a matter of what's outside your norm and not necessarily some other guy. I've done this 100 times. Who cares? I've never done it. So I want to go through the paperwork. If you're in doubt, talk to your supervisor and we'll hook you up with whatever you need. Field level risk assessments are totally valid. They can be used anytime, just as a good exercise, even if it's not maybe by the book. Who cares? The book says if you're unsure, do one. And that also enforces your supervisor to sign off on it too, so then they have to be involved. Operators must be familiar with the controls and operating characteristics of the crane, such as push button response, travel speeds, and stopping distances. So that's testament to knowing the piece of equipment you're using. You probably know exactly how your crane works. These guys share 4 cranes, so they have to get used to all of them. Again, but if you're throwing in a different building, a different bay, it's going to be a different crane. Don't think it acts the way your crane does. Just like cars. Every car is different. You gotta know what the car you're driving. Just because your buddy gives you his keys and says, yeah, she's fucking good, go for it. Yeah, okay. You're the one driving on the highway when the brakes fail. Look at that. That's our sign. We'll take 20. If you need to use extra people, go for it. One thing I can't stress enough around here is often we are tasked with doing things on our own, but that doesn't mean we have to do everything on our own. If we find a situation where an extra set of hands is necessary, get them. No supervisor should be finding fault with an employee asking for assistance for 5 minutes for a lift. It's so much easier than things potentially going wrong, and struggling will take longer. If it takes you 20 minutes to do it by yourself, or it takes 3 minutes to do it with a partner, you're saving time.
Well, and every supervisor that we have is going to tell you if you need help, get it, no matter what it is.
Exactly.
And everybody that we work with
is
willing to help.
No, there's always an extra set of hands available. That being said, try to make sure the extra set of hands is also competent. Don't ask the laborer who's been here for a day, hey bud, come help me with this critical lift. But maybe there is an opportunity for them to help, but realistically they should be trained, at least have this training. So, make sure you have the right person for the job, but that is also how we get less experienced people experience. So use your better judgment on that stuff. Operators must not engage in any activity that will divert their attention from operating the crane, so don't wander along holding a pendant in one hand and the fucking cell phone in the other and talking to your wife or what have you. Put the phone back in your pocket, communicate when you're done, don't get distracted. Operate the crane only when fit for duty, and that's fit for duty is such a loaded term. That can mean anything. I mean, yes, hopefully you're not high or drunk. That's the baseline of fit for duty, but that could be prescription medication. There's going to be personal things in our lives that take our attention away from our job. If something's going on at home, that's real life. Kelsey hates it when I say it, but this isn't real life, it's just work. Our real life is what we do this for, so we can afford to live the lives we live when we leave here. And if shit's going sideways or whatever's happening there, and you're just here going through the motions, maybe you shouldn't be running cranes or driving equipment. There's no harm in telling your supervisor, hey, I'm going through some shit. I don't think I should operate a forklift today, or hey, I don't think I should operate a crane. Unless your supervisor's a complete asshole, they're going to say, no problem, thanks for telling me. Even when I was a foreman in the field, I had days where I had family stuff going on, surgeries and hospital visits and stuff with the family and parents and shit. And I would tell my crew, if I'm not in it today, just be aware, my mind's not here, it's at home. And they're like, okay, thanks for telling us. And then if I seemed confused more than usual, they would know that it was just because I was dealing with real life. And there's no harm in admitting it. We're all human. We all have other things to think about. And that doesn't mean, your medication might say don't use powered mobile equipment. That's true. Hopefully you didn't drive here. But anything can take your mind away from this shit. And if you're not in it, don't do it. Don't put your coworkers or yourself at risk because you were arguing with the wife or the kids or whomever, wife and the girlfriend, whatever, and now you've got to pretend to use a crane safely. You should always be giving what you're doing 100% attention, especially when what you're doing is lifting heavy things with powerful equipment. So, wear your appropriate PPE as per manufacturer and employee requirements. When it comes to crane operating around here, there really isn't much PPE except steel-toed boots. The one exception to the only PPE you have to wear at LJ at all times if you're on the shop floor is safety glasses. The stipulation is such that if you aren't doing heavy lifts, you can get away with not wearing steel toes. Obviously, for all you guys being worker bees, you're going to be wearing steel toes at all times, but that is how the office staff get away with not always wearing them. That being said, if the engineer is working beside you while you're doing heavy lifts, you should probably have steel toes on. So just keep that in mind. Not that you're going to go lighting up an engineer for having his friggin' loafers on, but that's kind of the rule around here. Or if you're working in the yard, you need to have the steel toes because they have the shank at the bottom. We really don't wear gloves doing everything around here. I mean, obviously, I hope you are when you're welding, but you might have them off doing other stuff, or because of the magnitude of all the hot stuff you work with, gloves are probably handy, so you don't touch something you're welding a minute ago and scald yourself. But for a lot of what you guys do, gloves are not necessary 100% of the time. We have yet to get to that point. We might get there eventually, but for the moment, we can take gloves off, so there really isn't much except for steel toes. And we don't have any need for hard hats because we're not doing overhead loads. If we were to start doing a lot of overhead loads or potential overhead loads, we would probably need hard hats as well, but again, we avoided that. Lift planning, factors to consider, potential danger to workers in or near the load path. So if there's people in other bays and you're flying something across the shop, talk to them. You know, don't pick something up at the edge of the pad and fly it through the whole shop into your bay without telling the guys in the other bays that you're going to be floating this stuff past their doors, or vice versa. Blind spots or doorways. Again, one of the biggest blind spots we have here is probably that hallway by Ali's office, because people can obliviously walk out of there right into the crane path, forklift path, whatever it might be. Otherwise, things are pretty wide open, and we should be able to see things coming as long as we aren't nose deep in our phones and not paying attention to the world around us. Moving equipment such as fork trucks, slipping or tripping hazards, absolutely. If in the winter we bring things in from outside, we get puddles on the floor all the time, we wash things, we bring them in. Hell, in the winter we use shipping as a wash bay, and we actually use the pressure washer in the building. Same thing with rentals, so that creates a lot of potential slip hazards. So just have your wits about you. Good housekeeping is a huge thing too. Complexity of the lift, potential for the load instability during the lift due to shape or load integrity, center of gravity of load relative to pick points, shifting of the load weight, example, fluid-filled removable parts. We did have a boom arm in building 2 a couple years back that had it was an articulated arm that had a joint in the middle that flexed. There were pins that existed to hold it in position. Those pins were not installed before someone tried to lift it. So when they lifted it, the whole thing just flopped over into the floor. I was Neil playing with a boom arm years ago. But be aware of what you're lifting. If what you're lifting has the ability to flex or shift or change shape or whatever, take that into consideration and either isolate it or control that movement. We don't lift anything that's fluid filled around here, thankfully, but that could be an obvious problem if you start getting 1,000 pounds of liquid sloshing back and forth while you're folding something across the shop. Obstructions or tight-fitting areas, those are definitely things we do come up against, though that might just be the object we're loading things into. If you're building a manipulator, you're going to have a lot of other things around it that you could run into as you're installing parts on the base. Complexity lift continued. If the load needs to be turned over, that's one of the most common things we do around here. Most of the shit we turn over, with the exception of like the big one you talked about, is pretty straightforward. Standing up a weldment from the flat of the pallet onto its, like standing it up, that's trivial. You're lifting up a 400-pound piece of steel with a 20-ton crane. It's not all that crazy. There's really not much that can go wrong. But if you're flipping over a 30,000-pound, 20-foot-long cement-filled piece of steel, there's a lot of things that can go wrong. So you got to put, and it's round to boot, so it wants to roll on the floor. There's just so many more things you got to worry about. But the basic stuff we do here. The one thing we recently added to our JHAs when it comes to flipping things over is officially don't flip things over on the stands. If you're trying to stand something up, pick it up, put it on the floor, stand it up, pick it up, put it back on the stands. Do not roll things over in the stands.
The only time that I won't bring it to the floor is like with our master booms.
I was just thinking that. I know we do kind of roll those up onto their edge, but they're narrow and the stands are wide. But even in doing that, you have to be super cautious.
Oh, and we are when we do it, and making sure that like if it's close to the edge, we pick it up and move it to the back side of it,
and
so
then
it rolls to the center. But yeah, like it's pretty much for all of us. It's like if we need to pick something up and move it and reposition it, it goes to the floor.
Yeah, put it on the floor, put it on a pallet, put it on cardboard. With assembly, especially because you're dealing with finished goods often, you want to have something soft-ish there to protect it from the concrete. Welding, you're using mostly raw goods or raw weldments, so you have a little more forgiveness. But yeah, when in doubt, take the extra minute, put it on the floor, manipulate it on the floor, and then reposition the slings and put it back on the stands. We should not. We've had a few things fall off stands because people were trying to flip things over in the stands or stand them up in the stands, and that's just a recipe for disaster. So try to avoid doing that. Again, I guess there are exceptions, but it needs to be the right people doing it who are aware of the right way to do it. So if you've never flipped something over, don't just try it. Get someone who has, get the experience, and learn by doing. Tandem lifts when you're using multiple cranes or dual hoists. Type of lift is unique or infrequently done. That's one of the biggest reasons. These are two of the biggest reasons we're going to do a field double hazard assessment, is if we're doing something unique or if we're doing 2 cranes. Special means or access required for attaching or moving rigging. Yeah, we've done the odd thing where we have to use a man basket or a scissor lift to access the rigging when it's done. Again, not too out of the ordinary, but things to consider. You might have to make sure you leave space on the floor to get the man basket in there or the scissor lift, to take that hook off the top of the manipulator. Environmental conditions, effects of wind, thankfully not too big a concern. I think we all wish there was more wind in the building right now, but there isn't. Ambient temperature, more of a problem in the winter than the summer. Visibility, fog, glare, lighting obstructions, precipitation, and lightning. Again, not most of which aren't really a concern in the building. Crane capacity, loads is significant compared to crane capacity, so that would be kind of critical lift. If you're 20-ton crane, you're lifting a 19-ton object. That's probably a critical lift. You're going to need to be a lot more aware of what you're doing. Factors that can affect the maximum crane capacity. Increased loading when separating a load or releasing a stuck load. And they're going to tell you this a few times. Don't use a crane to release a stuck load. If you've got things that are frozen together, rusted together, don't just tug on with a crane. You have no way to really know the strain you're putting on that equipment. Find something else. Use a pin bar to get or some wedge or something to break the objects apart first. Don't just pull harder with the crane because you just have no idea what you're doing. Dynamic loading such as abrupt starting, stopping, acceleration, or deceleration. Accuracy of load weight calculations. And again, if you don't have we learned yesterday briefly how to calculate load weight. It's a good trick to know if you can. Another option is obviously documentation. When in doubt, overestimate. I could assume this table weighs 100 pounds, but for all I know it's made of lead. I should assume it's 1,000 pounds and put more slings on it. It isn't going to hurt. The slight difference between a lightweight sling to the next highest capacity sling is so negligible, you might as well err on the side of caution. And if you're doing calculations and you calculate something to be 1,200 pounds, use 2,000 pounds. Round up significantly, unless that takes you close to like the crane capacity. But for all the basic shit we're doing around here, just assume it weighs more than you think it does, and a fair bit more, and you'll probably be safe. Potential load shift, so things moving in the air, and the weight distribution between multiple cranes. Again, if you are using multiple cranes, there's certain ways to do it, and you have to be mindful of that. Obviously, you don't just leave here thinking you're qualified to do multiple crane lifts. Plus, you can't. It's pretty tough to do 2 crane lifts without 2 people. So you're going to have to involve other people anyway. Rigging capacity, side loading of rigging hardware and attachment points. If you need to pick up the object over here, but the crane only comes to over here, move the object to the crane with a forklift or a pallet jack. Don't just pull the crane over and hook it up and drag the thing across the floor. We've definitely had people here who like to do that. Derek thought that was the funnest thing in the world. I don't think you ever met Derek, probably. Remember that red-headed stepchild?
Oh,
Derek?
yeah.
Okay.
Yeah.
He used to think that was a great way to occupy his time when he wasn't standing around vaping. And it's just terrible for the crane, terrible for the rigging, bad for the product, the floor, all of it. The complexity of the rigging arrangement, the weight distribution or transfer load within the rigging arrangement, and environmental conditions such as temperature or chemically active environments. Thankfully, we don't really have chemically active environments around here. The worst thing we got to worry about is the heat and welding. I guess there's oil in the air and machining, but it's not so drastic it's going to explode or anything. Adverse commercial impact, if the load has significant replacement time. That's a big one around here. We spent 6 months building a manipulator. We do not want to fuck that thing up. You need to make sure we're doing it right, that everything's proper. Usually those are engineered pick points. But either way, if the thing is expensive, it could be worth $1 million. We definitely have some big expensive projects, and we just can't afford to replace them. And we definitely lose face with our high-end clients if we told them, sorry, we fucked up your expensive toy, and we can't give you a new one for 6 months. That would not make us look good, so consider that. Failure to complete the lift could create project delays or work shutdown. Same thing. Repetitive lifts. So this is the most common thing we do around here is repetitive lifts. I'm sure when Clark's building a batch of weldments, he's doing the same thing over 100 fucking times. Not necessarily loving the fact he's got to do it, but he kills it anyway. But it's just the repetitive nature of production. It's what we do. If you're doing custom, you might be doing a different lift every time. But if you're doing production, you could be doing the same lift over and over for days, and you just start to not notice what you're doing. And that's one of the biggest things that can get you in trouble. So watch out for complacency. Standard lift plans, a basic lift plan are all factors that could affect the safe lift have been evaluated. So that's kind of like our regular JHAs. Determine if the load handling activity can be accomplished through standard practices and procedures using common methods, materials, and equipment. A verbal plan may be sufficient in some cases. And that verbal plan's a big one. We do have a few people around here who get excited when they see something they're not used to. But as long as if you and I are lifting something and we talk about it, I don't care what the guy coming in from the office says. You and I have agreed we're comfortable, good or bad. I mean, just because some onlooker from the outside walks in and goes, I don't like this, that's his prerogative, and we can talk about it after if we really need to. But for someone to interject in the middle of a lift because they see something they maybe don't like, take it with a grain of salt. Obviously, anybody can stop a lift, especially if they're a supervisor. But we just need to be mindful that as long as the people doing it are comfortable and they've warned the other people around them might affect, some uninformed individual who comes in and doesn't like the way it was done, we can have that conversation after. But that has happened, and they might. And the reason I bring it up,
unless they have a legitimate concern,
of course,
unless they saw something that you didn't.
I guess the reason I bring it up is because they will often say, "Did you do a lift plan?" You'll say no, and then they'll get antsy because you didn't do a lift plan. Well, do I need to? If you and I agree we're doing it in a way that works for us, and we're the ones doing it, do we need to do a lift plan?
Well, if it's not critical lift or it's not completely out of our scope.
Exactly, and that's all I'm getting at, because I know these things have come up, particularly in assembly. Certain individuals get excited, and it is what it is. It's their prerogative, but again, legit safety concerns. Someone says, stop the lift, fine. There's probably something wrong. But if they just come out and pick apart what you're doing or tell you you're doing it wrong and ask for paperwork, take it with a grain of salt. The main thing at the end of the day is that you and the people doing it, agree that what you're doing is fine. So, but I mean, that being said, if you can't agree or you think you should, take the 5 minutes and write something out. That's not a bad idea either. And sometimes you have to safe out the area, put some ribbon up just to exclude people from the area if need be, but usually a conversation will go a long way. And they say most guys are happy to take a break or leave for 5 minutes and come back when you're done. A critical lift plan is an in-depth lift plan where all factors that could affect the lift have been evaluated. It's determined that the load handling activity exceeds the criteria for a standard lift plan and requires additional planning, procedures, or methods to reduce the higher risk. A detailed written plan is required. And we have these available. It forces you to draw pictures, plan out who's involved, what their roles are going to be, get the supervisor to sign off on it. Basically, that everybody accepts, not the risk, but everybody's on the same page and knows how it's going to be handled for the best lift possible. That being said, something else that commonly happens when you start looking for information is everybody has an opinion and everybody wants to stick to their plan and nothing happens. I've had that happen many times in the field. You get 3 or 4 people together who know what they're doing and nothing happens because they spend the whole day talking about what they could do and never fucking actually do anything. And as a foreman, I used to have to get in there and say, we're going to do what he says, just fucking do it. Because I trust him implicitly, and if 2, 3 stand around for another 2 hours talking about it, we are not going to get this job done. So sometimes you just have to trust your gut or trust someone who knows what they're doing, and you got to go for it. But usually with what stuff we're doing around here, it's fairly straightforward, and there's really not that big a risk. So, personnel should identify tasks to be completed before, during, and after the load handling activity, and the personnel need to complete each task. Again, all too often around here, you are the personnel. You're doing all of it yourself. You're getting the rigging, you're rigging it up, you're running the pendant, you're physically handling the thing yourself. Again, is it ideal? Not always. Could it be better if we had 2 people? A lot of the time. So take all that into consideration, I guess. But odds are most of the time you're going to do all that stuff yourself. And ensure the competency of all involved. Again, if you're running a lift, doesn't matter if you're a journeyman or a laborer, or if you're trained and you're running a lift, and you decide to grab someone to help you, you probably don't want to grab the summer student who's here for a month and has never seen a crane in their life. Maybe that's not the right person. Make sure you grab someone who is comparably trained to you, who you have some faith in. Pre-lift review. Before carrying out the load handling activity, all participants should communicate and agree on the details of the plan and their assignments. Again, for most things around here, it's 1 guy, it might be 2, and that can be as simple as I'm running the pendant, you're running the thing, and we'll talk. Okay, cool. That's all it really takes. Concerns raised during pre-lift review should need to be addressed before proceeding. Yeah, if someone has a valid concern, we need to make sure we find a way to handle that concern before we just go and do it. But some concerns are more valid than others, but either way, we need to entertain all concerns. Formal hazard assessment or field FHA must be in place for operating overhead crane to identify existing and potential hazards and methods used to eliminate or control them. So that's our job hazard assessments. must be current, involved affected workers, and reviewed in the last year or when work processes change. So this is exactly why every single year we have to go through our JHAs and review them. It's how we make sure the documents are up to date, and how we make sure everybody has read them relatively recently, and why every new hire gets stuck reading that whole book and signing off. Have you reviewed your hazard assessments for road crane operations? Hopefully all of you have done them fairly recently, because right now we should be doing our annual review. So
Pretty sure I have to do it again.
yeah, and you should keep
you
it
and I
away a
still
lot.
have to do ours.
Yeah.
We're on the list. We were at school when it came out. So.
It's true. So you guys are playing catch up, and I think you guys actually did all yours fairly early on in welding.
I think some of us have to go through coming up here soon.
Fair enough.
Yeah.
But that is why we do it every year, and we usually around here seem to wind up doing it every, we'll call it 14 months, not 12 months, because it gets caught up in fucking bureaucracy and delay, and call it excuses, usually on management part. We don't make time. Yeah, well, oh well, you just still got to do it. It is what it is, but that's why it's literally in the code that we have to keep doing this stuff to keep it somewhat fresh in everybody's head. And there's no harm when it comes to job hazard assessments if you're training someone new or someone impressionable. If you do have one of these summer students working with you, take a minute, take them over to the book, review it with them. It's a great thing as a journeyman to do with an apprentice. It's a great thing to do if you're working with someone who's inexperienced. It's just a step in the right direction of making that safety culture. And before they do something that's new to them, and it's a good reminder for you too. So field level hazard assessments are the ones we do at the time of the task, because it's a new or unique task. It must be conducted if a new hazard is present, not identified in the formal hazard assessment. Must identify the methods used to eliminate or control the new hazards. Must be signed off by all personnel and the supervisor. And must be updated if changes occur during the day. Who here has completed FLHAs? I think both of you guys probably have. Definitely don't. It just says who's completed FLHAs at their company. I know you have. I kind of assume you
I
probably
think I've
have.
done a couple.
Yeah.
Yeah.
As an installer, you should be doing them when you're doing the installs. When you're at,
We should be, yeah.
you might not be doing that anymore, but it's been drilled in, or at least it's been attempted to be drilled into the heads of the people who run the installs, like Ellis and Tony.
Yeah.
Is when you guys are on site, you should be doing one of these as a live document. Where it goes, ideally it gets put in the database just to show we're doing our diligence.
Yeah.
But it's also because you are no longer in the comfort of our facility. You're at an unknown facility. It's fresh. It's new. Different people. How are you keeping yourself and the company safe? And I'm pointing to you because I know you don't want to do them anymore, whether you do or not. It's debatable.
No, it's
but it is something that we should have been doing.
because what if their crane's not inspected or something? You just
Exactly.
go and use it, right?
Well, and I know, well, I guess every company is different, but being out in the field myself, I know that every job. When I was in the oil field, we did one every day.
Oh, and that's me
It was
too.
a live document, and if you were a contractor coming in, you absolutely had to be.
Yep, and I mean, I've been at sites where every different module we went to, we had to do a new one because it was a different environment. Like I might have been working on this one this morning, now I'm over here. Every time a crane would move from one module to the next, they have to do another one. Like it got pretty intensive. When you walked onto a module, you have to find everybody on there and sign off on theirs. Like read it, of course, and sign off on it. Because if there was insulators, like it gets pretty heavy out there, especially in dynamic environments like construction and out in the patch. How diligent people are is varying degrees of give a fuck, I guess. But the process has gotten pretty hefty. Around here, we don't do it, but I know something I have stressed is, when we've got our people on a completely alien site, even service, frankly, if they're going out to Worley Cord, they should be doing it. Because now you're working at Worley Cord and you're not here. And
You should almost do it more if more people that don't work there are using your equipment, right?
Yeah, and that's just it too, right? So for anybody who's transient and gets around being an installer or a field technician or whatever, those are times where things like this could really be useful. It forces the person to think, which naturally keeps them safer, and it proves the company has some friggin' give a fuck because we're keeping these documents and proving we're doing our diligence even when we're not in the comfort of our own facility. So for Clark, I don't expect him to be doing one very often because he's doing the same thing every day in the same space that he's in control of.
Well, even as if you had done one, right, and something happened, for OHS to say, well, where's the victim?
It's one of the first things they're going to ask, and that's the biggest thing. Is if something were to go wrong, and that's when it comes to safety, that's what it's all about. No one cares when everything goes right. The second something goes wrong, where's your paperwork? I didn't do it. Okay. Now this place is getting in trouble. Not even you, it's going to be potentially LJ that's up shit creek without a paddle because they're not making their staff do hazard assessments when they're in a foreign environment.
Then there's obviously the trickle down like fines and
Yep.
stuff like that. And
Except that in this case, it's trickle up. And that's the one thing about safety too that I've had to literally beat into management's head. It's not a matter of you being in trouble for whatever you're doing. It's your supervisors now and shit. It's now it's the general managers and shit because he didn't make the supervisor do it. Now the president's and shit because the president has an office here on site and runs the show. And ultimately might have decided, no, we're not doing that this year. Okay, well, if you were on a beach collecting a check, you would be safe. You are not. You have an office, you have a title, you can't play the I don't know card. So it actually trickles up. Shit flows uphill when it comes to safety, and they'll go all the way to the top. If we killed someone, which is the ultimate fuck up, it can go all the way to the top. Like it's not going to be the little guy at the end who's just doing what he's told. It's going to be the top dog who's sitting there going, I didn't want to spend that in the budget this year. Okay, but yeah, now someone's dead.
Yeah.
So, yeah, and that's why we really need to get better at doing some of these things. Again, it's not a matter of when things work fine, it's if things don't work. And part of it, things will work better if we all communicate, and this is one of the best means we have to do it. I mean, I've done thousands of these things in the field every single day for years, because it's just what you have to do, multiple. Muscle strains or musculoskeletal, or whatever they call it. Muscle strains are common when removing chain slings, large rigging hardware, and other load handling equipment from storage racks or attaching or removing rigging from the crane hook. It's also possible to sustain muscle injury when pulling chain slings by hand from under a load. Of course, we should be putting a load on dunnage or something so we can get things off it easy. But yeah, I mean, we noticed yesterday some of the heavier objects have the weights on them. That's not so we know it's 100 pounds and don't hurt our spine. It's so we calculate that as part of our load. But in saying that, there are rigging hardware out there that are really heavy. You have those big ass magnets floating around. They're fucking awkward, man. Like, you pretty much need to use the crane to move them. But if you want to be the hero, I'll go grab it. Yeah, now your back's fucked because you decide to lift a 100-pound magnet and cart it across the shop. Don't do that. Ideally, those kind of things are kept where the crane can get. I know Rich used to keep his magnets on a cart. He could drive them over where he needed them, put them in the crane. He never lifted those things. It would have hurt. That fucking magnet right there we used to keep the door open. Even it's heavy enough if you had to cart it around the yard very far. It just wouldn't be very fun. So take all that, and hopefully the shop takes that into consideration and sets your shop up so that the heavy things can be lifted with the crane and not by hand. But like any general material handling concern, ask for help. If you can't handle it, ask someone to help you. Put it on a dolly and roll it across the shop. Whatever you got to do to avoid carrying heavy things, and then you start running the risk of slipping and tripping and falling while you're carrying heavy things, and then things get just awkward and people get hurt. So it's also possible to sustain muscle injury when pulling chain slings the other way. Use the crane to lift heavy rigging and below the hook lifting devices from the storage racks. Get help attaching or moving slings, and use proper body mechanics. Feet shoulder width apart, back straight, hands pulled in close to the body, and lift with your legs, not your back. Yeah, you'll see that. Use good ergonomics as it's written into a lot of our JHAs, and this is what it's referring to. You should be, and you need to know you'll also see over and over in the JHAs, know your limits. Because Dave's limits are not going to be the same as mine. He's clearly weaker than I am. Just look at him, he's a little fellow. No, I know, but the beard gives you power, bro. Right? Whatever you don't have in muscles, you make up for in beard strength.
Fucking Samson.
But everybody's created, not everybody's created equally, you know, and WCB might say 50 pounds is your max. Some places want you to lift 100 pounds. You know, everybody's not able to do the same thing, so know your limits and what you need help with, and don't think you have to do it because you have to play the role of the hero. Not everybody can lift the same amount, so get help and find different means of doing it. Environmental considerations, working at extreme temperatures, can't imagine doing that anytime soon. Glare from the sun and sunburn. A lot of sites will make you wear long sleeves as much because it keeps the UV off you from the welding. It also keeps the sun off you when you're out in the heat. And it's amazing what that does to keep your body temperature down when you don't have the sun beating off your skin. Blowing dust in windy areas. Something I used to find in the yards when we'd get dust storms and shit that was actually really helpful was if you're outside in dusty conditions, put a face shield on. So it might look funny if people are like, what's the guy walking around the yard with a face shield on? Well, when the wind is smattering you in the face and sandblasting you with all this shit, you appreciate it. So it's just something to consider. touching hot or frozen loads. Again, welding, you're going to have hot loads, bringing stuff in from outside. You could have frozen loads. Again, not a lot for chemically active environments. Welding flash, of course, can literally blind you if you get caught with an arc. So that could temporarily blind you while you're doing a lift. And obviously just the inherent dangers of welding flash. And noisy environments is something we do have around here. Maybe when you're doing your lift, you turn the radio down and someone turned up because they want to hear Van Halen. Not that anyone around here would ever turn up Van Halen, but you know, you'll be playing the entire Van Halen playlist. But either way, there's nothing wrong with minimizing noise if you can. Turn down the shit you have control of. You know, wear earplugs if you need to. But that being said, make sure you can communicate with anybody else involved with the lift. Signals go a long way, but around here it's more going to be voice than signals. Environmental hazard prevention, wear proper clothing, control exposure, and follow work rest schedules and extreme temperatures. One of them, usually that applies to cold. We used to have that pretty in depth when it got super cold. But hot is just as bad. I mean, when it's cold, you can put on more layers of clothing. When it's hot, you're fucked. I know that Dave tried getting naked a few times, and we all told him no because he was hot and uncomfortable. You can only get so naked, okay?
Just saying.
Now, hey, I mean, you know, I'm sure there's a few people who are all going to go about it, but there's also, all jokes aside, when it's hot, you can only get so unclothed and
Until
stay
you get
so
arrested.
cool, right? Then it becomes a whole other issue, an HR matter, decency, and blah, blah, blah. People point, laugh, whatever, you know, whatever you've gone through. Either way, extreme temperatures do play a role. If you're sweating balls and sweat's pouring down your face, your glasses are fogging up, that is not the right time to be doing a lift when you can't see what you're doing. So take all that into consideration, make the best judgments you can, take breaks. Like right now, we should be taking cool off breaks, cool down, whatever. Go sit in that cold lunchroom and take the edge off. We've had a few people take time off in the last week or so because of the heat already. So I did order a whole 100 more of those neck fucking wrap things, kind of for the whole place because they're not expensive. And if you guys need neck wraps and welding to keep it cool, we're going to have a whole bunch hopefully arriving today. Yeah, like whatever we can do, drink lots of water, take breaks, just tell your supervisor, hey, I got to cool off. Come sit in one of the air-conditioned environments, whatever you got to do, obviously within reason, but don't push yourself in this heat. It's way too easy to do so. And I know one thing we discovered the other day too is eat. I know I had someone not eating because they were, it's too hot, I don't feel good. Yeah, but you still got to eat. You have to maintain that fuel for your body because your body's pouring through the calories just sweating.
Well, there's that too, but you're also losing a lot of salt.
Exactly.
And, you know, if you eat, it helps replenish some salt so that it actually keeps you feeling good.
Yeah, and
Because once you deplete your salts, then no matter how much water you're drinking,
it's not going to help.
You can still end up feeling super shitty.
So that's just it. Don't think because it's hot you should drink lots of water. Don't eat. Still eat. I mean, if Gatorade has its purpose. We used to provide it around here. That hasn't happened recently.
Oh, they just bought it flat on the other side.
Of course they did.
Well, Jacob did.
Of course you. Okay, well, no one over here has bought it recently. But either way, it's also, this week's been chaotic. But it is something that's helpful to have. We have, in the past, got those electrolyte replenishment sticks you pour in your water. Those are also beneficial. Honestly, it's nice to think the company's going to look out for you, and it's not that the company shouldn't. But let's be honest, we're all adults. Like sunscreen, the company's not going to give you. Bring your own. If you need to bring a Gatorade or two or whatever electrolytes, bring it. If you know you're going to be sweating your balls off all day, take care of yourself. Bring stuff for you. I mean, if you have to, the gut truck's probably going through a shit ton of Gatorade right now. But those things do help out. Look out for yourself to some extent. That being said, the company should be looking out for you too. But freezies don't replenish your salts. They're just a nice way to cool off and take a break. It's usually because you eat the freezies somewhere where it's cool, not so much because the freezie's really doing anything. But I know in the past, on hot days, we buy freezies, which, unless you're wrapping them around your neck, aren't really going to do much. They'll give you a sugary treat when you should be having electrolytes and water and a break in the cool. So, yeah. Yeah. Whatever. Everybody, the thing is unfortunately we are consistently inconsistent around here, which is why I stress at the end of the day, look out for you, because you guys might have bought a flat, but that'll go very fast, and maybe it's best if you bring a couple in for yourself because you know you need it. So it is what it is. Never touch hot or cold materials without wearing protective gloves. Wear safety sunglasses and face away from the sun or welding process. Obviously, you don't want to be staring at bright lights while you're trying to do rigging. Wear sunscreen to protect against sunburn. Wear adequate eye protection in windy areas where dust is blowing around. Use insect repellent to reduce the risk of biological hazards from insect bites. Wear adequate PPE when working in chemically active or noisy environments. Again, same thing. If you're working outside and bugs are an issue, bring your own bug spray. It'll help. Crane operator must be familiar with the manufacturer's specs, instructions, and recommendations. The employer is responsible for making them available and ensuring they are followed. If in doubt about any lifting application, contact the manufacturer or consult a professional engineer. I mean, we have, as Dave pointed out, you did consult our professional engineers what a lift you were doing. Whether they're expert engineers, a particular thing you're doing is debatable, but they're a good wealth of information and definitely give you an informed position on certain things. Touching on kind of what we went through yesterday, weight estimations. I hope it doesn't get as in-depth, but that's the basics, and this is the main thing we got to remember is that density. That question on the test fucks everybody up because they forget to account for the density. So you calculate your length, width, and height, which gives you the volume, but then you have to multiply the volume by the density to get the mass of that particular substance or object. And for, again, this is like kids learning new math in school nowadays. It doesn't make any sense to me, and I don't care what my kid does and how they do it. I just want them to get the right answer. But in this case, the new math for rigging or for weight calculations is to pretend a pipe is not a pipe. It's a flat piece of steel. And I mean, if you get it, it makes sense. It does work. It's easy enough to calculate. Hell, you could literally run a tape measure around a circular pipe. Oh, you can come through, Kels. It's all good. You're always welcome. Come on through.
You might hurt something on your way through.
I won't cut through on the way back.
So yeah, you could literally just wrap a tape measure around a pipe. Is it going to be perfectly accurate? Fuck no. It's probably going to be longer, so you're going to overestimate. But who gives a shit? If you know that pipe is a half-inch thick, like most extra heavy pipe is a half-inch thick, cool. You can take your tape measure, wrap it around there like you would check your waist kind of a thing. And, okay, so it's roughly 30 inches. That's going to give you effectively your width by calculating the circumference without having to use pi or anything else. And then times it by your length, and you'll figure it out. And your density, and then you will figure out. So your weight is equal to your length times your width times your height, and this works for any shape, really. I mean, hell, worst case scenario, you can pretend like it's a solid piece of steel, not a piece of pipe. Who cares? You're going to way overestimate. Who gives a fuck? Again, overestimating is really not going to do you any harm. If you're working from a moot and you're lifting entire modules or a whole bridge or another crane, yeah, okay, fine. You're probably going to want to get it more dialed in. If you're working here lifting a piece of steel out of a rack, it really doesn't matter if it's perfect, and if it's more, who cares? How do you find the center of gravity of symmetrical load? Again, they tell you to find the center in all directions. They're not wrong. Again, my simplified version of this is that if it's a symmetrical load, don't worry about finding the center, just measure an equal distance from the ends. Because if you put your slings on the same distance, it's going to pick up level. You don't have to take the time to figure out how long it is, divide by 2, how wide it is, divide by 2. It'll just work out. Center of gravity of a non-symmetrical load. So this we went through yesterday. We're going to break that thing down into its constituent parts. We have 2 boxes instead of 1. And then we're going to figure out where the mass lies in between them. So we calculate the weight of A and the weight of B, divide the 2 of them to figure out the difference. And then our center of gravity is going to be 66% of the way. So we take the mass of the heavy one divided by the total mass, gives us 67%, or 2/3 of the way between the 2. They're going to show an imaginary ruler, which doesn't make any sense because it's intense, despite saying inches, which isn't a thing, but whatever. The premise is the same, and then that tells you where your center is going to be. But in doing that, I mean, this would be fine if you were wrapping a choker around here and a choker around here. I don't know what the hell you'd be doing here. This is just showing lines into a box, which I guess there's pick points there already, in which case you're going to just use the pick points. So it's a useful skill if you can figure it out, and in the event you have to get it right the first time, absolutely. And if you find yourself in an environment where this is essential, you'll probably learn it and it'll become super simple. Around here, we're not doing things to this advanced level. It's really not necessary, so don't lose any sleep over it if it doesn't work for you. A competent rigger is required for non-standard lifts involving difficult rigging arrangements and potentially unstable loads, such as offset center of gravity, uneven pick points, or a center of gravity above the pick points. Again, if the center of gravity is above the pick points, the thing is inherently unstable. If I tried to pick this table up and I put my slings down here on the bottom, well, it's top heavy, it's going to flip over. So those are things you have to consider and find ways to mitigate that risk. Employer must determine if the crane operator is also a competent rigger, and by employer in this case, we're going to say it's going to be your supervisor. I can determine if you can pass this course, but at the end of the day, your supervisor says, hey, go lift that with a crane. That person better know that you're capable of doing that, and if you're not, you two better have a conversation and figure it out. So key points to remember: inspect slings for damage before use, because it's always the end operator or end user who's responsible for the slings and the pick points themselves. Protect all slings from damage, so use your softeners and edge protection and all that good stuff. Don't exceed slings rated capacity. Don't stand on, under, or near the load while the sling is under tension. Maintain and store slings properly, so make sure you put them back where they're supposed to be, out of the way, ideally away from UV, indoors, up off the floor. Don't just toss them in a pile in the corner. Examples of removal criteria for all slings and hardware: missing or unreadable sling identification, that's the biggest one. If you can't, read the tag, don't use it. Evidence of any heat damage, so that could be spatter, could be miscolored because it's been hit with a torch. Fittings that are cracked, bent, twisted, gouged, or broken. Any other condition that causes doubt or for continued use. So if you don't like it, don't use it. Let someone else make a decision as to whether it should be used or not. Slings should not be shortened by knotting or twisting. Slings must be hitched in a manner that provides control of the load and prevents the slings from slipping or sliding along the load. So that's deciding whether you're going to use a basket or a choker or a double basket or like a double wrap basket. It all depends on what kind of a bite or grab you need on that object. Slings should not be constricted, bunched, or pinched by the load or any fitting, so don't stick a 4-inch sling to a 2-inch shackle. Sure, you might be able to force it in there, but it's not going to do good things for that sling. Slings should be centered to the base of the hook to prevent point loading. Hands, fingers, and body must be kept from between the slings and load, sling and hook, shackle, and other load handling devices. If the center of gravity is known, attach the slings to the load at equal distance from the center of gravity. Blank degrees horizontal or bigger, so it's 60 degrees or bigger. So ideally you want to have that nice 60-degree equilateral triangle. That gives you only a very little increase in tension, but still gives you good control. The length of the slings must be equal to or longer than the distance between the pick points. The increased tension is approximately 20%, so that's the 1.4 or 1.14 of the equilateral 60-degree triangle like that. But don't forget, I can't remember if they tell us in this one, but yesterday we learned if we take this all the way down, so this is a 30-degree angle, you're actually effectively putting the entire mass of the load on each sling just by the physics that it creates. If there's so much tension on those things, trying to pull them together, your 10,000-pound object is putting 10,000 pounds on each sling. That doesn't mean your crane's holding 20,000 pounds, but it does mean your sling is effectively holding the entire weight of that thing. So keep that in mind. Center of gravity approximated on equal loads. Again, it's a little more complex, but in this example, a double leg chain bridle must have a capacity greater than 10 tons for the type of hitch being used to avoid overloading a single leg, because that one single leg might actually have 10 tons worth of strain on it. Shackles at load must have a capacity greater than 5 tons each. When you have center of gravity is approximated, position the load, crane hook above the center of gravity, attach the chain and bridle. Lift the load slightly off the floor to check for level. If it's not level, put the load down and readjust your slings. And this is how most of us are going to do it. If it doesn't want to lift up level, put it down, wiggle your slings around. You'll quickly learn if you're moving them the right way. Move them towards the heavy end to spread the load out more, or farther away from the light end to make the light end heavier. Again, this is all stuff you'll get used to as you become competent, and you do this over and over. It becomes kind of second nature, but to the uninitiated, it can be kind of confusing. Shorten the chain leg at the heavy end, and lift the load slightly off the floor, check the level again. So it all depends, and don't forget that not every load has to be level. If you're just picking something up, moving across the shop, who cares if it's level? As long as it's not unsafe, like a 16P or a 30P, when you lift them up by the engineered lift, it's going to lean. Because who cares? If you're just transporting it across the shop, it doesn't have to be perfect. You don't have to put 2 more slings on it. Now, if you're installing something or positioning something where it has to be just right, you might spend an hour getting it just perfect so you can get that thing in position. And again, when that thing weighs 10 tons, you have to get it right with the rigging. You don't have the luxury of pulling on it to get it to fit. You can't, oh, just pull it down when it gets there. You can't. You can hang off it and nothing's going to happen. You just have to get it right. So it really depends what you're doing. And around here, it rarely matters if things are perfect. Inspect the crane operating area for hazards and clear if necessary. Use barrier tape to cordon off the area if needed. Ensure there is sufficient clearance for the load along the entire load path. Address additional site-specific safety concerns. So anything else that might come up, be it people coming in from the hallways, other crews in the area, whatever might be up. Clear the destination of all obstructions and slipping and tripping hazards. Yeah, you don't want to be worrying about tripping over stuff. One thing I like to point out at all times around here is the assembly is a pretty dynamic environment, and you guys do a hell of a job keeping things tidy over there. But always look out for stepping on things, and one thing I like to point out is pallets. We all walk across the shop and step on pallets, but that's actually a great way to break your ankle. Pallets are notoriously flimsy sometimes. You have the gaps between the boards. You have cardboard over top of it. You can step on that pallet and lose your foot between those boards really easily, or break right through them sometimes. So try to avoid even stepping on those when you're doing this stuff. The last thing you need to do when you're carrying a load across the shop is trip and crack your ankle because you stepped on a pallet. Use suitable blocking or dunnage for easy removal of things by hand, and sometimes you even have to put dunnage on pallets because if you're setting something on a pallet, you still need a way to get the slings out from underneath it. So you might have to put 4x4s or 2x4s and the like on the pallet to facilitate getting the slings on or off the object. Shock loading is rapid lifting and fast feed without taking slack out of the slings. Well, that's one of the causes, obviously. So a great way, one of the things people often do wrong in this course and during their test is they get the rigging on, whatever we're lifting, and they just lift up. And they just lift it right up 3 feet off the ground, and then away they go. Anytime you're lifting something, lift it up just a little bit, get your slings tensioned, lift it up slowly, and then ease it up off the ground, have a look, make sure everything is the way you want it, and then you can fire it up, lift it up, and move it and do what you gotta do. But you should never just assume your slings are right and then start driving like you don't have to think again. Especially with heavy things, this is a great way to overload your crane, overload your slings. If you've got a 10,000 pound thing and you just get up on the crane, it's not gonna be good for your rigging or your crane. Obviously, with a lot of our small stuff, it's probably less of a concern. And odds are, whatever we end up lifting this afternoon is going to be crazy small, because I usually just pull random chunks of HSS out of the pile outside the sheeting, because they're easy to manipulate and it's easy to put back, and nobody misses them. But they still give us a chance to operate. Moreover, the biggest cause of shock loading is abrupt shifting of the load due to unstable rigging arrangements or sudden arrest of a falling load. So if you've got multiple slings and one sling breaks or something shifts or slides and that thing falls a few feet and then stops, that's where shock loads start to matter more. And obviously the heavier the object, the greater the shock load, the farther the distance that it falls. This is why we don't consider standing up a mast, and that little shake it does at the end it's a shock load technically, but is it going to hurt the crane or the rigging? Fucking better not.
What little shake?
Okay?
What little shake?
Nothing. We never have it. It never happens.
Not to me.
No, you're the best.
I know.
I think we all do. And it's not because you keep telling us. But, okay, fine. When you're flipping over a weldment and it does that little drop, I know you're just fucking around. But we've all done it. It's almost unavoidable. And yes, if you're just right, some days you get that one where it just lifts up easy and you catch it and you're like, fuck, I'm awesome. I mean, you do this every morning when you wake up, I know. But the rest of this morning stretches, look at me. But all jokes aside, we've all done, or most of us have done it, and you will get the chance eventually to do it as well. But some people on the outside looking in, they see that little shake and they're like, incident. The person doing it knows it's going to happen. You can see it coming, and there's ways to minimize it, but it's also, you need to consider the physics. If you've got a 500-pound weldment and it falls 6 inches, how much force is it building up and falling 6 inches? If you know physics, it's what, mass times acceleration to figure out your force. Well, this much with 400 pounds is not going to be enough to overload the sling, the shackle, the crane. It's just not. Now, if you're standing up that 430,000-pound concrete filled thing and it does this after falling 2 feet, fuck yeah, that could definitely screw some shit up. But but we're not doing that on a regular basis. And when we are, we need to be taking all that into consideration. For our day-to-day, I'm sure you roll shit over constantly because you have to get in and around and outside. And I know you guys stand things up all the time and roll things over. We just have to use a little bit of common sense as to what is the actual impact of that impact. And usually it's negligible. But I mean, I've seen cranes get shock loaded, the whole crane shakes, the boom starts swinging, whatever it might be. I've seen things roll over in the air because they do a 3-point pick on an L-shaped object, and one of the slings fucks off, and the whole thing drops and falls 20 feet. It can get pretty sketchy. And then you start looking at actually shock loading. And when you legit shock load cranes, you have to get them like inspected mag particle, looking for microfractures, all kinds of things can go wrong. And it's often not going to, if that happens, it's not going to break today. It's going to break in 6 months after some more abuse. But you can do the damage or start the damage today that 2 months later might cause the crane to fail. So if you were involved in a shock load that's bad enough, on an overhead crane you can actually shock load them enough that they bounce off the tracks, you flex the friggin' beams, the wheels can become capsized sometimes. Like, it can get pretty ugly. I've never seen any of that happen, thankfully, but if you're doing something that weighs 40,000 pounds and it flips over and falls, nothing's going to stop it. It's going to be ugly. It's going to break the slings. At the very least, even if it falls 6 inches, that's a lot of mass. Falling 6 inches, it's a whole different story. It just gets crazy. This 1,000-pound thingamajig, if it's on a jib crane, yeah, okay, maybe that's going to be a problem. If it's on a 20-ton crane with oversized rigging and it moves a foot, you're going to be okay. So take this just into consideration and be mindful of it, and definitely don't just hit the up button when you go to pick something up, because that will definitely shock load things, especially if you're moving a heavy piece of equipment. Slings must fit properly in the base or saddle of a hook. Ideally, they don't overlap. That is hard to pull off depending on what you're doing. It can be really difficult. One of the ways we avoid that around here, though, is because most of our cranes have those chain hooks. We can literally put a sling in each hook. So now it's only one sling in each hook. We don't have to put multiple slings in one hook. We have multiple hooks. But if you do have only one hook, you want to be mindful of how those slings are sitting on top of each other. Don't overload them. Put in shackles. Put in multiple shackles if you have to. You can put one shackle in the hook and a shackle, multiple shackles off the shackle. There's ways to do things. If you don't like the way it looks, just ask. Maximum 2 sling eyes permitted on the crane hook. So again, don't put 4 sling eyes on one crane hook. Does anybody remember what the maximum angle between the slings on a crane hook is? This is a test question 2. And there's the picture out of the book that they show us. So 245s make for 90. Some hooks will have the marks on them just as a visual reminder. But that's because because of those forces that are involved in everything trying to pull apart, when you start getting your angles way out here, it could actually physically stretch the hook or damage the hook. And we don't want that to happen because that's setting us up for failure. Synthetic slings must be protected from abrasive or rough surfaces on the hook. Yeah, I know what's happened here where during inspections, daily inspections, people have found little burrs, little things on the hook. If there's a little burr, take a file it off. If there's a big fucking gouge, okay, we're probably going to get it inspected by a professional, but you are allowed some damage or some wear on the crane hooks, on the hooks. 10% is kind of the guiding rule. Whatever the initial dimension is, you can lose 10%. But I mean, if you've got 3 things that reach 10%, that's not cool. And I know I've seen people file off burrs on crane hooks because you don't want to put a sling against the burr, and then when you pull on it, it just tears the thing in half, cuts it. So always keep an eye out for things like that. It does happen. Secure unused sling legs back to the master link. We do that here all the time. If you've got a 4 chain bridle and you're only using 2, hook the other 2 back up to the master link so they stay out of your way. The load must be completely unrestrained and free to lift. 10 o'clock, you guys want to take a break, go for a dart, stretch your legs.
Go for a coffee.
Go for a coffee. Take 10 minutes in the capacity of it, and we replace them every few months or whatever because they're dirt cheap, really. So that's the solution we've discovered that works really good and it's effective. And in theory, it forces us to look at them and replace them. There probably is another option out there, but this is a fairly cheap solution that works really well and has been working well for years. So, but that allows them to weld on the piece, and obviously they put their ground somewhere near where they're working. And in theory, the power just goes between the ground and the bead. But in the event it tries to get away, they can't go back and screw up the crane itself. So That's how you mitigate that in the welding department. Otherwise, there shouldn't be any welding happening on anything that's attached to a crane. Wire rope, load chain, or hook must not be used as a ground for welding. I don't know what you would be doing that you would end up using the crane as part of your circuit for welding, but obviously someone's done it because they see fit to remind us not to. So do not use your crane as part of your welding part. Never attempt to pick up or place a load when the hoist lines are not vertical. So yeah, if there's that kind of box where your crane can reach, if you've got things outside that box, don't just drag the crane over to it and pick it up. That can do all kinds of bad things to those drums, the way things are go wrap around the drums, and it's just, plus you're imparting all that, the side pull, the friction, all things you can't really quantify, and you might overload things. It's a great way to bunker things up. Just get a pallet jack, get a forklift, whatever you got to do to move it across the floor until you can get the crane on it. Dangers of side pulling, and there's an example of what can happen when you do things like this. You can end up doing damage like that. If hoist lines are not vertical, the wire rope could be forced out of the drum grooves, which can cause damage to the wire rope, the rope guide, and the sheaves. If load is not directly under the hoist or bridge, an underhung hoist could tip onto only 2 trolley wheels, which could damage the girder or cause the trolley to be pulled off the girder. So it's all things actually this is something people probably wouldn't take into account. Is the trolley itself can capsize when you try to drag a load. So there's just all kinds of reasons why you don't want to do this. It's just a bad idea. Stand in a safe operating position with a clear view of the load path, destination. Do not wear gloves that can interfere with the operation of the controls. Ideally, the person running the controls isn't wearing gloves. If they are, hopefully they're pretty tight fitting and they can reach everything properly. Make sure there's no tools or loose material on the load. That's a big one. I know in the past, I would lift up a unit, and because some units will tip, if you leave your tools on top of it, those tools are now falling on the floor or potentially on you. It's kind of like the old don't leave tools on the top of a step ladder, because the person who comes and cleans up after you will pull the step ladder up, but that shit will fall on their head. Same idea. Try to avoid leaving tools on equipment. Obviously, we have to if we're building it, but before you lift it, look around, make sure there's nothing on it. Sound the horn or shout, stand clear. You can sound the horn. Sometimes you have to sound the horn to get the crane to start anyway. Shouting stand clear probably isn't necessary. Realistically, around here, talk to whoever's nearby. Just say, hey Joe, I'm lifting this thing, I'm putting it over there. He'll say, okay, if you might need to leave, whatever. Just communicate with your coworkers in the area. It goes a lot farther than randomly making noises that no one listens to, because everybody assumes those noises don't apply to them. Take the slack out of the sling slowly, so raise your hoist, your block up, watch your slings, take the slack out slowly, and stop when the slings are tight. Move the trolley or bridge to ensure vertical hoist lines, so make sure you look at your crane from both angles. If you're standing over here trying to lift the table, don't just assume that you'll be able to see if you're good north-south, but you might have to walk around and check to see if you're good the other way, because obviously you have to be good both ways, but when you lift it up, it's going to fuck off in the direction that it's out. Again, how much that matters depends, but try to get it as centered as possible. Continue up to to lift the load about 1 inch off the floor and stop, check that the hoist brake is holding and the load is level and stable. So get it up off the ground, have a good look at it, make sure it's sitting the way you want it to sit, make sure it's stable, and then you can proceed with your lift and pick it up as high as you need to and travel as far as you got to go. Lift only high enough to clear immediate obstacles and never up to the upper limit. Yeah, like I said, my general rule of thumb is lift it up to about the height where you can touch it with your open palm without having to bend over. There's no need to lift up high unless you have to clear other objects. Conversely, don't lift it 2 inches off the ground and have to walk along with your leg bent over. That puts you in a position where you can become unstable and fall over, and you're going to fall into the load. Bring it up to whatever height's comfortable for you and transport to where you got to go. Watch for load buckling. If you're lifting up something flimsy that can bend, be mindful of buckling and use appropriate rigging to mitigate that risk. Watch for crush points and possible load snagging. Be careful to avoid bouncing the load while lifting or lowering, or shock loading when you're bouncing things up and down, and potentially even when things are swaying left to right or what have you. That is causing potential shock loading if it's significant enough or fast enough. And definitely the up and down, you just want to move. Most of the time, lifting in slow works good. Try to avoid the high speed. There's not a lot of need for it. The upper limit switch is usually set so that the hook block will rise up between the girders, so that would be like the 220 tons in building 2. All the rest of them, it's all underneath, they're all underslung. The lifting beam can contact the girders before the limit switch operates. Avoid rapid acceleration and deceleration of suspended loads, which can result in increased stresses on both the crane and the rigging. So again, that's a form of shock loading. Everyone involved with or affected by the lift must be in a safe position for the duration of the lift. So if you've got 2 people involved, make sure you know where they are and what's going on. In this case, they literally have a wall built for whatever reason in between what they're lifting and where the people are. So you want to have signal people, spotters, whatever. In the unlikely event you have to have multiple signal people, which I've done lifts where you have to have 2 signalers. Again, consider the delay that all takes. If you're down a hole with doing a lift and your fingers are underneath something and the crane operator's up the hole and off to the side, you might have to have a signaler with you, a signaler at the top of the hole. Again, I'm using a hole as an example, but where there's no line of sight. And you've got to take into account when you say stop, now you've got to relay that signal between multiple people to the crane operator and have the crane operator physically do the stop. And that can take a few seconds depending on how many people are involved. So you kind of have to take that into consideration. When you want things to stop, you might have to actually say it ahead of time so it stops when you want it to. Again, it's minor, but it's just things you have to consider. And you'll learn it really fast. How come when I say stop, it doesn't stop? Well, it takes time for your brain to talk to your hand. Definitely takes time for your brain to talk to 3 other hands. There are 5 people removed from you. Like there's that delay. So consider that. The more people involved in the lift, but make sure everybody's in a safe position. They can all ideally see each other, and everybody looks out for what's going on. Crane operator should stand behind and to one side of the load, and that's ideal, I guess, depending on which way you're going. The main thing is you put yourself in a position. One thing you'll see over and over again in our JHAs is always have an escape route. And that literally means if shit goes sideways, make sure you have a way to get the fuck out. If something was to fall, make sure you have a way to back up and get away. Don't put yourself between the load and an object, obviously, like a wall. Always have a way to get away from whatever can go wrong, if it does go wrong. So leave yourself an out. The signaler is required if the operator can lose sight of the load at any point along the way. One or more tagline handlers are required to keep the load from rotating or to rotate the load during travel. Again, that all depends on what you're doing. Sometimes you need multiple tagline handlers. Again, it all depends what you're doing, where you're going, and how you're getting it there, and what it is. Always check the directional sign of the crane before pressing a push button. Again, this is more important if you've never used the crane. More often than not, the directional sign, north, south, east, west, is going to be pretty close to the planet or the globe. Ideally, that's north. Hopefully the crane doesn't say that's south. It's confusing. Then again, I've worked with an awful lot of people who have no concept of north, south, east, and west on a good day anyway, so it might not matter. But the main thing is that you know the crane you're using and what direction each button is going to go. The assembly building is actually slightly angled to the globe, so it's not exactly bang on, whatever. Again, the most important thing is you know the one you're using and which button does what and which direction it's going to go.
And underneath the IV usually has the directions.
Yeah. Sound the crane horn or give a loud verbal warning such as watch out, mode moving. Again, whether you're screaming things randomly into the ether and anyone's paying attention, you're much better off for the 3 people who might be near you. Hey, I'm moving this. Okay, thank you. Yelling random things out is not going to really, no one's going to notice. The guy who's halfway across the building isn't going to care. So just communicate with the people around you. Don't use fast speed unless it's safe to do so. Fast speed, honestly, can get you into trouble faster than you need it to. Most of the time, slow is good enough, even if you're transporting things across the shop. The other problem with fast speed is your fingers slip and they move. You start going fast, slow, now your load's doing this. Unless you're very competent, which like you might be very used to your cranes and you're comfortable, but wait till you get comfortable. Try to avoid the fast until you're very comfortable with the crane you're using and you know what that's going to do. And obviously with a heavier object, the fast speeds will have a greater impact. Once it starts to swing, it's going to swing for longer. And it's going to be harder to stop. It's often, if you're just moving things around in a small space, slow is usually fast enough. Watch for changing conditions and don't leave a suspended load unattended. conveniently yesterday, Kelsey and I were walking out of friggin' assembly, and there's a roller for a 20 or for a 810 CRR 810, just sitting there floating in the middle of space, no one around, just hanging from the crane, 4 feet off the ground, no one anywhere near it. Okay, not cool. Like, if you're painting things and you're using the crane to lift them up, paint them and then lower them down and leave them close to the ground if nothing else. Try to avoid leaving things 4 feet off the ground and walking away. If you're near it, so be it. You're in control of it in theory, but you should not be leaving things floating in space and running off to coffee. Lower it down to the ground, just touch it on a pallet or something. Again, unless you're using a magnet, don't do that because then you take the mass off or a clamp. But consider it what you're doing and make sure you safe it out before you walk away, and just don't leave things floating in the sky and walk away and go to the bathroom or something. Do not use the end stops as operational means of travel stops. So don't just run your crane into the end stops as a way to stop the crane. Most of the time the cranes will only allow you to get to the end stop slowly anyway, but there are some jib cranes you can smash it right into the end stop, no problem. Again, that will eventually wear the end stop out or potentially break the end stop off. Don't continue pushing the travel button once the crane or trolley has come to the stop against the end stops. Ideally, they're smart enough not to do this, but maybe the older ones or some of them aren't. You'll literally burn the motors out, cause undue heat, the wear, tear, whatever, because you're running it up against the end stops. Don't use cranes outdoors when the wind speed exceeds safe working wind velocity. Again, not an issue here. We haven't gotten the outdoor cranes, but if you do, then you need to consider the environmental conditions, especially the wind. When the crane starts moving, this is a good trick if you can master it. The only way you're going to master it is if you practice it. We're not going to practice it in this course. Woo. Oh, you go ahead. You go through. Sure. No worries. Probably have to get in that room anyway, do you? Yeah. Yeah. All right. So they'll walk us through the theoretical process of using the crane to stop the swing. Have any of you guys practiced this in the shop? I
have tried it.
Yeah.
You go with the swing.
Effectively, you're trying to catch it.
Yeah.
And I know Shane's a huge proponent of this, and it's a good trick. And I mean, I've tried it; it works, but it takes a lot of fiddle fucking to get used to it.
Yeah.
And it's going to tell us the steps of start your forward halfway through your backswing. To try and remember it all is honestly probably not going to happen. What's going to wind up happening is if you find yourself trying to do it, you're just going to try to do it and realize, oh, I'm doing it wrong. I'll try this, and you'll end up figuring it out as you go. But the important thing to remember is, in theory, and again, it matters more for heavy stuff. Those light things, you can use a tagline or your hand. If it's just swinging a bit, put your hand on it. You can tell if it's going to push you across the room. If it weighs 20,000 pounds, doing this is not going to stop it. It's going to push you right off and just keep on swinging anyway. Taglines help because you can pull it tight when it goes away from you, and then let it go limp when it comes back, and then pull it tight again, and you can eventually take the swing out. So that's another reason why taglines are helpful on heavy things. But you can, in theory, use the crane to stop that swing, but it's explaining it on a piece of paper or a slideshow is not going to do justice to when you actually have to do it. So when the crane starts moving, the load lags behind. We've all experienced this in cars and everything else. Always start in slow speed, increase speed. That's the biggest thing, is when you start to roll any direction, start in slow. If you start in fast, it's going to make that bigger division because the crane's going to start moving, and then the load's going to catch up and it's going to start doing this. So start in slow speed and then speed up to fast speed. Never just hit the gas all the way. Much like it throws you back in your seat in your car, it's going to cause a distance gap between the crane and the load, and then it's just going to swing back and forth like a pendulum. But then they're telling us you can stop it. In slow speed, the best time to release the travel button is when the load has swung back to the middle after its front swing. So if you're going in this direction, you're going right, and it's swinging back and forth, you want to let your finger off the forward button or this direction button when the load swung back to middle. So it's come this way, and then it's come this way, and that's when you stop it. But again, not to mention, now you have to figure all that out while you're moving towards your destination, and the odds of timing all that right starts to get pretty tough. So it's more like when you get to where you're going, you're just going to back your crane forward and backwards in whatever direction you have to try and catch it and stop that swing. And you can do it, and sometimes it's pretty drastic how fast you will take that swing out, but you just have to get it right. And no amount of book study is going to prepare you for this. So much like standing things up and rolling things over, the only way to really get good at this is to practice. So if you find yourself in a position where you have time to fuck around with getting used to this, I highly encourage it, but it's not going to be something we can spend hours on today to try and master.
Well, and to be fair, welding is very packed up. They've got shit all the way around. Downstairs in production has shit all the way around.
Yeah.
Assembly definitely has shit all the way around. And trying to catch a load that's swinging, you're just going to smash into shit.
You could.
That's what's
Yeah.
going to happen. So,
And again,
just take your time.
Yeah, and that's why don't go in fast if you don't have to. If you're positioning something next to a manipulator, don't fucking hit fast. If you'll smash the mast or something. And consider your environment. Absolutely, we're all in pretty close quarters. There's lots of stuff around, so fast speed is not often necessary when you're traveling. Usually, you're picking something off a pallet and moving it 10 feet. You're not likely moving it. I mean, you might you pick things up at the far end of the bay in Lance's area and bring it all the way to yours.
Barely.
You're really just dealing with shit right in your bay, basically, right? Yeah. So it's not like you're going to be going in fast speed and having things swinging wildly. Again, it can happen. It's good to know that this exists. And like I said, if you get the chance to play with it, go for it. You might wind up being a chance whether you plan to or not, because all of a sudden you've got a heavy load swinging. At the end of the day, if you just wait, it'll stop. Like Dave said, just take your time. There's not a lot of need to be going fast. We're not being whipped to go faster. If there's still some swing remaining, it can be eliminated by catching the load. This is done by waiting until the front position of the swing and pressing slow speed push button in that direction long enough to catch up the load. But again, the problem with all of this is now you're moving your load while you're doing it because you're moving your trolley or your bridge, and now you're getting farther away from where you need to be. So if you're lifting something heavy, honestly, put a tagline on it, get a second person, because then you can manually control that swing. It might take a minute because if it's heavy enough, you can't just pull it to where it needs to be, but you can slowly remove the swing if you're trying to land something heavy very specifically. Inching the load. Inching is brief, intermittent push button activation to accurately position load. Inching must only be done in slow speed. Not a lot of point in trying to do it fast. And again, inching is pushing the button repeatedly. It's not a video game. Pushing it faster isn't going to make it do anything. You're not trying to level up and get more coins. You're just trying to move things. So it's going to be a methodical click, wait, click, wait. This is how you can burn out the contactors if you do it too fast. Inching must be done with extreme care to prevent overheating of the motors, reducing their service life, or welding of the contactors, resulting in a runaway crane. And that is a very real concern. Again, we did have the welding of contactors get welded on the one crane. Thankfully, it was the up and down function, and it wasn't totally welded. It was kind of sporadically grabbing, but it did start to happen, and it could have gotten much worse if we hadn't identified it and got it dealt with right away. Lowering the load, ensure everyone is clear of the load. Lower the load carefully and slow speed only. Avoid starting and stopping repeatedly, as this creates load bounce. Watch for possible snagging. Keep hands, feet, and body parts out of crush points, and don't reach under the load for any reason. The load should only be rotated by hand if permitted by the employer's hazard assessment, safe work procedure. If it must be done at arm's length, at shoulder height, with open palm. With open palm, good footing and balance stance. I'm not sure why they're saying rotate. I guess they're talking about rotating it around this way. Again, if you use your open palm, you're pretty safe, and just guide it to where you have to go. Try to avoid grabbing things because that can put your hand in a position to get your hand taken off, depending on where you are, what you're doing. And it might not be the load you're doing today. It could be the load you do next week, where it's, I grabbed the last one, I'll grab this one. It's just a bad habit to get into. But again, use your better judgment depending on what you're doing. Never put your hands into openings in the load, never under the load or anywhere where the rating or attachment point. Don't put your fingers in holes. When setting the load down, the operator must ensure the load is in a stable position to prevent toppling or turning. Obviously, you are responsible for that load. You are responsible for where you put the load and how it's going to, if it's going to stay put when you put it down. So if you're stacking things, make sure it's properly centered and make sure the thing underneath can support the weight of the thing you're putting on top of it. The operator must never put the remote control in their pocket. You don't want to pocket dial a crane. Go sit down in the lunchroom and all of a sudden the fucking crane's driving away in assembly. Thankfully, we don't have this problem here because we don't have remote controls. They are super handy. When I did work at a place with remote controls, the biggest problem we had was people fucking off with them. Usually ironworkers would just keep the damn things to themselves because they were their cranes, and then we couldn't find them. We'd have to go track them down. In a perfect world, there would be a place where you keep them and you can find them. Again, people being people, they would hoard them, they would hide them, they would try to keep them for themselves, which wasn't ideal. Not a problem we have here, but yeah, if you do find yourself working somewhere with remotes, don't throw it in your pocket and go for lunch. You don't want to be standing at the gut truck bullshit with your friend with the cranes fucking off in the building. It would be hilarious, but potentially quite dangerous. Before removing the rigging, press the E-stop button on the pen and remote. Good habit to get into. Basically, a good habit to get into is when you're done your lift, hit the E-stop button. This prevents anything from happening. It's unexpected. In the event your partner, or moreover, somebody else, let's say an old guy comes up behind you and grabs the crane pen and starts doing something, not realizing it's the crane that you're using and not the crane he's using, it won't instantly start moving, and maybe you'll see him. Not that that's ever happened around here, but let's just watch out for each other. Yeah, push the E-stop button when you're done. It's easy enough to turn it back on and fire the crane up when it's time to keep moving again. Remove all the rigging from the load by hand only. Don't use the crane to pull the rigging out from under a load. Inspect the rigging for damage that may have occurred during the lift. Again, you are responsible. This also prevents you from damaging it and then leaving it for someone else to find later. If you're actively involved in the lift that you're doing, ideally you should notice if you've caused damage. If you've, oh shit, I didn't notice that sharp edge, or oh shit, it snagged on that thing, or whatever, no harm, no foul, own it. If it's damaged enough, take it to your supervisor, say this is broken, get me a new one. They'll say okay. But don't just hang it back up on the friggin' rack for the next guy to find, because what if he doesn't do a previous inspection? If you're aware of damage, own it, take it out of service. If you didn't do it, even better, but you should catch it beforehand. But you know what you've put that reading through in the course of the lift you just did, so you know if there's a chance it's damaged. Clean steel rigging if needed. Oily or dirty synthetic slings should be tagged and removed to service, and visit the altar to prevent reuse. Return rigging to the storage racks to prevent physical damage, chemical damage, moisture, and UV damage. Move the crane to a location where it's out of the way. Bring the trolley to one end of the crane and raise the hook to safe height. That's a big one. One of the things beaten into me in my first weeks here was, for heaven's sake, make sure you park the crane high enough that forklift can't run into it. We are driving forklifts into all these buildings, so make sure that we park the cranes out of the way and lift the hooks high enough so it can't catch the mast of the forklift or something, and ideally find a nice safe place to put your pendant so it's not in the way either. Bring the pendant to one end of the bridge and secure it out of the way. Return the remotes to their designated location.
And just to point out that the forklift in assembly's mast is higher than every other forklift.
Yes, it is. Yep.
So in assembly, those hooks need to be higher.
Correct.
Than normal.
Higher roof and higher mast to boot, so it needs to go up higher to get out of the way of everything. And yeah, that Nissan's got the highest, tallest mast of anything we have here. Nissan, the big boy, but both of which do wind up in the building from time to time. This is the very basics of turning loads over. If you've never turned a load over, and I'm looking at you, there, Vitaly, because you've not really, don't just walk back into assembly and try this. Get Dave or someone who's been doing it a lot to give you a hand. It's a skill that eventually it's good to know for sure. I mean, Clark, I'm sure you've rolled 1,000 things over. It is necessary, and it's something you're going to wind up doing here eventually, but you're not going to learn how to do it from this course. Not practical knowledge anyway. I'm not going to go through the finer points trying to pull the software in our test. All I want to see is that you can basically direct the crane. When turning a load over, the optimum pick point is just below the line extending to the tipping point in the load center of gravity, and every load is going to be different, but this is also why we do it on the floor. If you do this on stands or something, it's way too easy for it to fall out of the stands, to shift in a way you don't expect it to shift. But the biggest thing with flipping loads over, besides putting them on the floor ideally, is making sure your hook is straight up and down. So you have to actively be moving the bridge or the hoist while you're lifting up, not just hook thing, lift thing. No. It will lift, it will swing, it will gouge the floor, it'll fuck off in the wrong direction, it'll shock load. You want to maintain that vertical lines and move the crane with the object, and that will minimize the amount of risk to doing this operation. Crane must travel while turning the load to keep the hoist line vertical, like I just said. Obviously, if you start having everything tipped over like this, you want to stop, because when you do lift this, it's just going to drag along the floor and then swing when it does come off the ground. When the load is lifted from above the optimum pick point to center of gravity, the load will not pass the tipping point. So there's going to be times where you have to use an object like a 4x4 or something to put put what you're lifting on to get it to tip the way you want it. And that's just one of those things where you kind of have to get used to it and try it out. Center of gravity position in relation to the tipping point determines which way the load will naturally want to lay down. So in this case, it will always want to go backwards in this direction along the arrow. When it does that little tip, it's going to want to shock load. Again, it's varying degrees of shock loading depending how heavy the object is. But you do want to make sure you select rigging that's going to be able to handle that. If it's a 2,000-pound object you're rolling over, grab a 6,000-pound sling or maybe even an 8,000-pound sling. It's hard to quantify how much stress you're going to put on the rigging. It all depends on how far the thing moves and how heavy the thing is. When the optimum pick point is not available, the use of a step block can help. So this is an example where you might have to put the step block on it, and that will help to tip it. Again, this is the kind of stuff where you're going to have to experience it. Really telling you how to do it with a slide is just not going to necessarily work. But there's lots of elements we left around here where we end up having to do this. When laying the load down, the step block should be big enough to allow the center of gravity of the load to pass the tipping point. The point will transfer from the stop block to the floor as the load is laid down. If the step block is undersized, it will not allow the center of gravity to pass the tipping point, and it'll just wind up stopping on the stop block. Choker hitch orientation. Place the sling eyes on top of the load, pointing the opposite direction of the turn. The body of the sling is then passed under the load, both through the sling eyes. It's a little convoluted. There, you can use a choker to rotate an object. And for any of you guys who've done a lot of rigging, you've all probably done this. You can roll things over with the choke. When you're rigging that up, take into consideration what we learned yesterday, that when you put that choke all the way down to the floor and you tighten that thing up really good, you're actually losing half the capacity of your sling. So make sure you grab a sling that's appropriate for the load you're lifting. Don't just get one that matches the weight perfectly, because when you do that, you're losing half the capacity. So make sure you double the capacity, I guess, on your sling or more. And you can manipulate objects with the choke. The choker hitch rated capacity must be reduced to the low angle of the choke as the load is turned over. When rigged properly, the turning action should tighten the choker, and if you don't do this right, you'll notice quite quickly it just spins around the object instead of biting where you want it to do. Again, this is something that's a lot easier to learn in practice than on a piece of paper. Blocking must be used under the load to protect the slings and allow for easy removal. Basket hitches should never be used to turn the load over. If you can roll the thing over with a basket hitch, good luck. Basket hitches are borderline useless for most of what we do around here. When in doubt, use a choker and then you get some control from it. And a good rule of thumb is if you're picking up an object with two chokers, make the chokes oppose each other, because then they'll kind of help to level it out. So if you were choking, say this, you would have one choke going one way and the other choke going the other way, and they'll just kind of work together to pick it up straight instead of wanting it to lean in the direction of the dominant choke, I guess you'd call it. When a load is attached to two independent cranes or hoist hooks, there's a potential to lift at separate times and different heights. There is. I mean, you're going to have probably, unless you have a control that can run both cranes at the same time magically, you're going to have two people doing two different pendants. The saving grace is if you both are going slowly, there really shouldn't be much of a risk if one gets a little higher than the other, but it's still something to consider. In both these cases, this is engineered pick points. This looks like they've just used baskets, so there is a risk if one side got higher than the other, the thing just slides right out. Not so much in the point of the one on the right, but work together, try to maintain the same thing. If one starts getting ahead of the other, stop, allow the partner to catch up, and try to keep things level. I mean, I've done lifts like this with two cranes where you have boom choke and you're actually intentionally capsizing it, so the thing is basically vertical. It can be a useful tool for installing things. It's totally normal to do it, but it requires great communication between the operators doing it. As a general rule, you just want to keep everything level. So definitely go in slow and not in fast. This is just going to show us how the mass is shared between the two hooks, so especially when one hook's disengaged and one's completely engaged. If one crane lifts first, it will carry 50% load only if the pick points are an equal distance from the center of gravity. The center of gravity is in the same plane as the pick points, and the blocking is just inside the pick points. So again, things you want to consider when you're choosing your rigging. If you're doing a 2-crane lift, again, making sure each piece of rigging can handle the entire weight will help when you're doing this, because you're actually changing the dynamics as you go above or below or touch the ground in this case. If one crane lifts first, it will carry more than 50% of the load if blocking is set outside the pick points. Pivot point will shift the center of gravity to the first crane. Again, they're giving us calculations. We don't necessarily have to worry about any of this. It's just good to know the dynamics of how the mass is going to be carried by the cranes. When both cranes lift at the same time, each will have 50% share of the load. Pretty self-explanatory. It's a 10,000 pound object. Each one's going to have 5,000 pounds. There's no sling angles. So there's no multiplying factors to worry about. When one crane sets the load down first, the other crane will have more than 50% of the load. When the pick points and center of gravity are on the same horizontal plane, the shared load will remain the same, even if one crane lifts higher than the other. So despite the fact that that thing's being angled at a pretty wild angle, it's still 50-50. When the pick points and center of gravity are on different horizontal planes, both cranes must lift at the same time to keep the load level to maintain an equal share of the load. So in this case, if you start having one lift above the other, it's not going to be 50% anymore. It's going to be more. So in this case, the one crane's carrying 9,000 pounds to that 15,000 pounds, and the other one's only carrying the remaining 6. It's absolutely critical that both cranes start and stop lifting and traveling at the same time. This requires clear communication, one person to be in charge of lift. So 2 crane lifts, I know in my experience, often there was one person doing the directing and then 2 people doing the listening. Again, it's pretty unlikely you're going to take an engine block or whatever the hell this thing is and somehow get it to be wildly capsized unless you need to. If it gets a few inches higher on one end, it's not really that big a deal. But it also depends. If you're installing a turbine shaft at a Genesee or something, you're going to fucking make sure that thing's right. Odds are you're going to use a chain fall or something to finely tune that thing. You're not going to be using a crane to dial in exactly how it sits in those bearings. It's going to be by hand, by feel, probably have a level on it. It just all depends on what you're doing. For something of that magnitude, you'd be hard pressed to get it very far out without someone being asleep at the wheel, basically. When one crane operator controls both cranes with a single remote control, the cranes will start and stop at the same time. That would be the optimal thing, is if you have that available. Cool. Obviously we do not, so it's not an option. Travel speeds vary between crane types and capacities. Great care must be taken to keep hoist lines vertical. Use slow speed only. The faster crane must stop intermittently to allow the slower crane to catch up. Hopefully you don't have 2 cranes on the same bridge or on the same rail that are wildly different. But that being said, you got 20 tons and 10 tons over there, so they're going to have different characteristics. If you were using 2 of those, or a 10 and a 20, you'd want to be mindful of this. But again, unless you're completely oblivious, you're going to see it, you're going to talk, you're going to keep up. When using only one hoist of a dual hoist crane, ensure the unused hoist is clear of all obstructions. Yeah, if you do have 2 and you're only using one, park the one you're not using as far out of the way as possible. Cranes with dual hoists, park the bridge and trolley in a designated spot, secure outdoor cranes for moving. Yeah, outdoor cranes, you don't want the wind to move them around. Something you'll see on tower cranes or even RT cranes, they have what's called the swing brake. The swing brake allows it to pivot in the wind, so when the wind's hitting that boom broadside, it actually allows the crane to spin freely, so the crane doesn't follow, which is just called their swing brake. And that is something that you want to make sure it's disengaged. I assume outdoor overhead cranes have a similar device that stops them from moving, so when the wind is hitting them on a windy day, it's not rolling down the tracks into a building or something weird like that. It's going to actually have brakes that manually stop it from moving. Secure the pendant out of the way and return the remote control to the designated location, and turn the disconnect switch off. Whether or not you need to turn the disconnect switch off is debatable. We really don't turn ours off unless there's a problem or repairs going on. We should be shutting the power off with the e-stop at the end of the day. It's a good practice to get into. And then date inside the operator's logbook. We're not dating anything at the end of the shift. We're just picking up where we left off tomorrow and doing another inspection. And again, basically, if you notice a problem while you're using it, tell your supervisor. Otherwise, hopefully the person doing the inspections is catching things. But the person doing the inspections isn't hanging 10 tons from it like you might be. We had a problem in assembly recently where the crane guys were here doing the service, past the crane, and the next day you guys were lifting something and the hoist started making weird noises because you were lifting a load and the crane guys who were doing the inspections were not lifting load. So things can still come up. Just because we had the professionals here yesterday doesn't mean the crane isn't fucked today. So don't assume, well, this guy did it, it's good. Clark checked it this morning, I'm good all day. Well, you should still be paying attention. And if there's a weird noise, there's still a weird noise. Things happen. I mean, hell, our big boy forklift is currently out of commission. It was working one day and wasn't working the next. We literally didn't do anything. The computer shit the bed somewhere overnight, and now it just doesn't want to start, and it's acting like it's possessed. So mechanical things go wrong even when you're not using them, and it's good to always be aware of the thing you're using. And if it's not acting the way it did yesterday and you don't like it, stop and ask a question.
Do we call a young priest an old priest?
What's that?
Do we call a young priest an old priest?
Yes.
Okay.
Yeah, and we'll get some holy water and a cross. We're gonna be the fucking big boy needs a damn exorcism right now. It's right possessed. It reset the hour meter to 0, and the language is back to Korean or whatever the fuck. Korean is what the tech told me. He's like, I can't make sense of what the menu's telling me because it's not English. Perfect. Whatever Hyundai is originally, I want to say South Korean. I'm not 100% sure. Either way, it's or Japan. Yeah, Hyundai sounds like heavy industries is what I want to say. But either way, it's reset to its original language, and the hour meter's reset to 0. There's lights blinking. There's lights that should be on that aren't. The transmission's shifting in and out of gear by itself. Like it's got something wrong with it. It's probably computer based. But one day it was working and one day it wasn't. So you never know. Electrical failure. So in case of an emergency, there's things to worry about when it comes to a crane, and power failures do happen, especially in the summer with these wonderful storms and crazy shit. So in the case of electrical failure, the crane loses power while the load is in the air. Runaway cranes, the crane function continues after the push button is released. And again, with those contactors fusing, that could happen. Mechanical failure, damage caused from shock loading, overloading, side loading, or general abuse. Procedures for cranes. Release the push button. Pretty self-explanatory. The first thing you do is stop doing what you're doing. Then press the e-stop button. It's kind of like when your brakes don't work in your car, you reach for the e-stop. It might not be the best idea. I don't recommend throwing it in a park when you're driving, when your brakes fail. I've tried that. It's not the best idea. Send another worker to get barrier tape and lock the crane out. Now this is assuming your crane's not still moving. If you've just lost power and you've got something suspended in the air, turn everything off, press the e-stop so that when the power comes back on, it hopefully doesn't start moving again. Get barrier tape, flag off the area, just keep people away from it. Stay at the pendant and ensure workers are safely away from the suspended load, so don't just abandon it and leave it there and run away. Stick with it, hopefully power comes back on. Cordon off the entire danger zone, which of course is the area the load can fall, fall, roll, or deflect into. So depending on the load, how high it is off the ground, and the things around in the area, you might need to flag off a bigger area because it could fall on other things or deflect into other things. If the crane has at any time been accidentally shock loaded or overloaded, it must be removed from service and a periodic inspection carried out to determine whether damage has occurred. So if you significantly shock load a crane, if you're flipping over a weldment, I'm not worried about it. If you're flipping over a 30,000 pound piece of concrete and it shock loads and everything goes bang, crash, vibrates, scares the crap out of everybody in the building, yeah, we're going to shut that thing down, we're going to tag it out, we're not going to touch it until the pros come look at it, because it's just the right thing to do, and we do not know what we've done to it until they tell us. A PSI, or potentially serious incident, is a serious near miss or close call that under slightly different circumstances could have resulted in personal injury, property damage, or loss. Report all near misses. So a PSI is something that gets reported to OH&S. It's not up to you guys to do that. It's barely even up to me. That'll be something that management has to sign off on before we call the government and confess our sins. But that being said, any near misses we have, especially with cranes, we should be reporting internally. We have the document to do it. Depending on the significance of it, we might be safing out the area, cordoning it off. It really depends on the incident. If you're in doubt, talk to your supervisor. There's no harm in saying, hey, this almost got really bad, we could have hurt someone. That's fine. Shit happens. The only way to not do anything or not have anything go wrong is not to do anything at all. The amount of dangerous shit that you guys all do in the course of the day, you're bound to have something happen over the years that could be bad, whether it's almost really bad, whether it's genuinely bad, whatever. Own it. Confess your sin to your supervisor. We may or may not do an investigation. If it's significant enough, we definitely will. And hopefully we can learn from the error that you made to avoid someone else making the same error down the road. Workstation cranes typically have an electric chain hoist for lifting and lowering a trolley for manual horizontal movement of load. Jib cranes, again, we have these in welding and in machining. Workstation crane, that's like our corbels in day one. Monorail crane, so it just makes me want to sing a song. Portable gantry cranes, monorail. I call the big one mighty. Portable gantry cranes, again, we almost bought some of these for assembly, but we decided we didn't want to give up the floor space to store the fucking things because when we don't need them, they'd just be in the way. Look out for oil drips, disconnects, or check the disconnect switch, the festoon cables, dependence cables, and restraint reliefs, the hoist functions, limit switches, hooks and latches, and the load chain. Trolley travel, check the trolley's smooth movement and evidence of damage. The trolley must not roll on its own. The jib boom for smooth movement and evidence of damage. The jib boom must not swing on its own, so hopefully everything is plumb and level and things stay put. Actually, this is a good visual representation of the travel stops. They look like they're just bolted on. That's another reason you don't want to be slamming your crane against the travel stops all the time. You're going to dislodge things and cause them to come loose, in which case you might literally be able to run the thing off the end, and that would be a crappy way to start or finish your day. Bridge travel, if it's equipped, check for free movement and evidence of damage. The bridge must not move on its own. When starting the lift, the operator should lift the load a few inches and check the hoist for proper load holding action. It's tantric. Load must not be lifted more than a few inches until it's well balanced, and the hoist must not be pulled by the pendant or the pendant cable. For manual trolleys, the operator should push the load using two hands outstretched off shoulder height. Of course, the only problem with that statement is that implies the operator has two hands to use. If the operator is using the pendant, they only have one. So again, in a perfect world, every crane lift would be two people. Because in a perfect world, you'd have one person manually handling the load and someone else running the hoist. This isn't a perfect world. Often we wind up doing this stuff ourselves. But again, don't hesitate to ask someone for help. The operator should not put their hands into any opening in the load over sharp edges or under the load. The operator must not run a manual trolley or manual bridge sharply against the end stops. When lowering the load, lower the load carefully in slow speed. Watch out for possible snagging. Keep your hands, feet, and all body parts out of the crush points. Not reach under the load for any reason. To maintain good footing in a balanced stance. All good, man. When positioning the load by hand. Remove and inspect the rigging for wear or damage that may have occurred during the lift. Again, you used it. You should know if anything happened to it, so have a good look at it. If you don't like the results of your labors, take it out of service, talk to your supervisor. Oily or dirty synthetic slings should be tagged, removed from service, and physically altered. So what they're saying is if you bugger up a synthetic sling, cut it, like literally cut the eyes out with a knife so it cannot be used by anybody else. Of course, the running joke is put it in your truck, take it home, and never let it see sight again. But either way, we don't want it on site. We don't want it where someone else can use it. We want to make sure we take it out of service and alter it so it can't be used. Park the hoist in a designated spot. Bring the trolley to one end of the crane or beam and raise the hook to a safe height. Press the e-stop button on the pendant. Secure the pendant out of the way. Turn the disconnect switch off. Dates on the operator's logbook. Holy shit, that is it. Man.
Oh my god.
I'm a gird. So, much like